just like open the music.
Do we need? Oh, it works. So, okay.
So, are we online? Okay, so telling you very welcome for the second day of Cloud Rejekts in the VIP arena. I hope you survived the first day very nice, had the nice talks, had the nice networking. And so we start with a security and identity topic today to get you hot on, on a good information flow. So I will hand over to the speaker and enjoy.
Yeah. Thank you. So there are two things that are good to wake up in the morning. So first thing is coffee, and the second one is my 100 plus slides presentations. So today we will go through one of these. And before the talk, I want to thank you people who made this talk possible. So thank you for KubeCon committee members for rejecting me. Yeah, okay, so my name is Maxim. I'm working for the company called Pelric. We are a service company, so you have probably seen the CNCF landscape. So with all the application, we may help people. So we may set up them, configure, deploy, and support 24/7. So this is what the service company usually does. And in my free time, I am the open source contributor. I usually contribute to authentication or authorization projects, and I'm also the maintainer of the project called DEX. So today we will discuss the new exciting feature in DEX called the token exchange and how we can use it to build the secure cloud native environments. And the introduction with a couple of jokes. Okay, done. So then we are going to tell what DEX is about. So some facts. DEX originally was developed by the CoreOS company back in 2015, so it's already 9 years old. In 2018, after the CoreOS acquisition by Red Hat, so it was like dropped out of the company, and now this is the community-driven project. And since the 2020, it's a CNCF sandbox project. We almost have 9K stars, 1.6K forks, and more than 25 adopters I personally know about, but probably there are more of them. So the main idea of DEX, what is DEX about? Usually people say that DEX is the identity provider, but it's not quite right. So the right thing is that DEX acts as a portal to other identity providers. So it can connect other providers to DEX. And this let DEX defer authentication to LDAP service. SAML providers or established identity providers like GitHub, Google, and Active Directory, and many, many more providers. And the idea is that clients just need to write their authentication logic once to talk to DEX by using the standard OpenID Connect client library that exists for basically any languages. There is one library. And then the DEX can handle all the other protocols. So the idea of DEX is like this. Yeah, on this side we have the standard OpenID Connect interface, and as input we can have many, many different protocols. And this is DEX. So why do engineers love DEX? It's ultralight. So this is just a single binary written in Go on approximately 35 megabytes in size. DEX is simple, so the code base is small, simple. You can just spend a couple of hours to get all the concepts that are used in DEX, so it's not that hard. DEX is Kubernetes native, so it was developed for Kubernetes, and it runs well on top of Kubernetes. We will discuss it today in details later. So DEX is community's building block, so it's not only used as a provider, but also as a dependency in other projects like Argo CD or Sigstore, so they're using DEX in their deployments. And DEX is true open source project, so this is a community-driven project, not owned by a company, so we are just surviving somehow without salaries. Yeah, so that's why engineers love DEX. Architecture. So we have DEX, and as I've told you before, there is a standard OpenID Connect interface, and through this interface we can connect users, by using the standard auth code flow, or we can connect also machines by using other flows like password credential flows, or the thing we will discuss today, the token exchange one. So DEX is a stateful service, so it needs to store somewhere the data, and there are many, many options. So first you can use the relational database like PostgreSQL, MySQL, or SQLite for this. But because the schema of the data of DEX is pretty simple, we can use even a key value storage. For example, we can use etcd to store data. It's also possible. And if we run in DEX on top of Kubernetes, we don't even need a storage, so we can use a Kubernetes as a storage. DEX can store the data in Kubernetes custom resources. And if we are just testing something, we can use in memory storage. This is not persistent, but for test, it's okay. And the final concept I need to explain to you is connectors. So we can connect other providers to DEX. For example, if you're a big enterprise company, you probably already have a key clock or Active Directory, so you can use them to authenticate through DEX. If you're a small company, you're a startup, you only want to write code and you only have Git repos, so you can use your Git provider for authentication. And there are also two special cases. The first one is local users. If you, for example, want to test your connection without the provider, this is also possible. Or the mock connector if you want to use DEX as a web server for testing your, I don't know, for your integration tests. So this is a mock connector. Okay, this is what I want to tell you about architecture. So this part is done. Moving to the next step, explain what token exchange is. So token exchange grant, the main reason why this talk is happening today. There is a special RFC 8936. Don't Google it. I will explain the whole RFC to you today. So this is the extension for allows to the flow that defines the token exchange grant. This is the additional way how you can get tokens from DEX. And this is not a new thing. So it was published in 2020, a long time ago. So, but in DEX it was implemented not so long ago, so like last year. Okay, but to explain the token exchange to you, I will explain you the real world thing that we use often, the currency exchange. So imagine you have a euro, and if you're a software engineer, you probably have more euros, even more euros. But this is before you paid taxes in Europe, so now you have just a normal amount of euros. And these euros, they're issued by the European Union. So there are special signs on coins, on banknotes, so you can verify that this euro is valid. And euros are used by different countries among the European Union, so you may go with the euro to France and buy a croissant here, yeah? This is possible. But what if we want to go to Japan and buy sushi there? It will not work because there is another currency in Japan and they do not accept euros. And this is just how the world works, yeah? We cannot have the same currency everywhere because of geopolitical reasons, because this is just not how the world works here. There are many different currencies. What can we do in this situation? So we may go to some strange guy and exchange the currency with him. So we may give this guy a euro, and in exchange we will receive the yen. And with yen we can travel to Japan and finally buy and enjoy our sushi. And there is a Scooby-Doo moment, so let's rip the mask off. And this whole time we were talking about token exchange, not about currencies. Yeah. Okay, so currencies there are JWT tokens issued by different providers, and sushi is the access we want to have to the server protected by another provider, and the strange exchanger guy is the DEX in this schema. So the token exchange in DEX, sorry for my pronunciation, but it was implemented by Sean Liao. This is the valuable contribution. So many thanks to this GitHub user. So it was merged by November 2023, and it's available in the latest version of DEX that was released in January 2024. And the thing that it works with other JWT tokens, and to be able to validate the tokens, DEX requires the provider to have the OIDC discovery endpoint. So to get the keys and to get the issuer to be able to check that tokens are valid for exchange. So, and yeah, the idea is simple. We have some JWT issued by another provider, for example, by Kubernetes, and there are sub and expire claim, and we can use these claims from original token as the base for other non-standard claims in DEX. For example, the sub and expiration claims will be different in the DEX token, but there may be some properties from the original token in DEX token. So that's how exchange works. Yes, so you can see that the subclaim from the Kubernetes token now becomes the name claim of the DEX token. To enable this feature in DEX, you only need to ensure that the grant is enabled, and it's enabled by default, so you don't need to bother yourself, only if you want to disable this. And we'll also need to define a connector. You can see the YAML file here for the connector. So the most important thing there is the issuer. And that's it. So this is all you need to do to start exchanging tokens in DEX. So it's easy to understand the feature because we have a good real-world example. It's easy to start because it's easy to deploy DEX in general. It's easy to configure. And this is the great field for experiments. So let's move on and discuss the practical use cases, how we can use this feature in our current cloud-native environment, how it's applicable. The first case is CI/CD integration. So the goal is to deploy to a Kubernetes cluster. So we always need to deploy something to Kubernetes. And there are two common anti-patterns. So the first one is to bring the kube config for administrator from the cluster to your GitHub runner. This is not good because if you lose this config, so everybody knows that this is not a good thing to do. Another anti-pattern is to use the service account token with the infinite lifetime. Also not the great thing. Instead we can use the token exchange feature, and there is a workflow illustration of how we can do this. So the actors here is GitLab CI/CD, DEX, and Kubernetes. So first thing, we need to connect DEX as a OpenID Connect provider to Kubernetes. So now we can use DEX tokens to go to Kubernetes. At this point, GitLab cannot access Kubernetes clusters. But what we need to do, we need to define GitLab as we need to connect GitLab to DEX with the connector thing. So because GitLab has the OpenID Connect Discovery endpoint, so we can point DEX to this endpoint. And now DEX can verify GitLab tokens. And this is the peak point of the, of the workflow. So on each pipeline execution, GitLab issues a token. And with this token, we cannot go straight to the Kubernetes API, but we can go to DEX, exchange this token, and then use it to access Kubernetes API. So pretty simple workflow. So, and this is not only GitLab specific case, so you can use it with other CI/CD systems. For like GitHub Actions is also a great example. And all major cloud providers allow authenticating using the CI/CD tokens. So you can go to AWS and create machines there. So why cannot you go to Kubernetes and create pods? So now with DEX you can. So now it's possible. And no more anti-patterns. So now we have proper short-living tokens. The second case is Kubernetes auth mesh. The goal is to give access to a service from one cluster to another cluster. So to to be able to control workflows from other clusters from the single one. It may be required for Istio multi-cluster feature, for example, to configure Istio multi-cluster. Or it's also maybe required, for example, for Argo CD to manage different Kubernetes from the single one. Okay, anti-patterns are the same here. Let's dive in the workflow. Actors here are DEX and 3 different Kubernetes clusters. First thing we need to do is to connect DEX as an OpenID Connect provider to all these clusters one by one. So the first one, second one, and the third one. So now we can use DEX tokens to authenticate in all these clusters. The second thing that we need to do is to define 3 connectors in DEX. So now Kubernetes registered as the authentication providers in DEX. So now can DEX verify their tokens. 1, 2, 3. So, and now it defines the whole mesh between these clusters. And now, from one cluster, we cannot go with the service account token to another cluster because it's not possible, right? But we can go with this token to DEX and exchange it, and finally have an access from one cluster to another. Yeah, some mind-blowing maybe example, but yeah, let's go further. And now I will show you how we can define a kubeconfig for such authentication. So we will use exec credentials plugin feature. And first we need to write our exec plugin, and we will use shell for this. The simple example, first of all, we need to get the service account data. This is our initial token. The second, that we need to exchange initial token with the request to DEX to add DEX token. And the third thing we need to do is just to return the JSON structure, and this what makes this shell script a proper exec credentials plugin. So the development of plugin is finished. Now we can go and save this plugin to the executable directory. We need to give this script execution rights, and then we will be able to use this script in the kubeconfig like it's shown on the screen. I want to tell you that this is not the production-ready script, obviously. So there are not error handling and other things, but this is just a simple example to show the idea of it, and it also works. So this is the full example. Yeah, so this was the Kubernetes auth mesh, and the third case is SPIFFE tokens. So the goal is to use SPIFFE tokens to have an access to Kubernetes API, because if we already have all our services authenticated, why cannot we use these tokens for authentication in Kubernetes API? So let's just see the workflow. There are now 5 actors, like the DEX itself, the Spire server, and the Spire agent. That we will use in our example to issue SPIFFE tokens, the application itself, and the Kubernetes cluster. First thing we need to do is the registration between Spire server and Spire agent. So we need to make the agent eligible for issuing tokens for all the workloads on a node. The second thing is that we need to register SPIFFE server, Spire server, Spire server as with the connector in DEX. So now DEX can verify these tokens. The second thing is that we usually do, we connect DEX to Kubernetes. So DEX tokens now accessible by the Kubernetes API. And then we can finally start our flow. So the application goes to the agent and gets the SPIFFE token. With SPIFFE token, it cannot access Kubernetes API, but it can exchange the SPIFFE token for a DEX token and then connect to Kubernetes. And with this schema, you can use SPIFFE IDs as usernames like this in your RBAC rules. And it makes service accounts in Kubernetes obsolete. So you don't need to use service accounts anymore in Kubernetes with this schema. Yeah. That's it. So we finally made it to the finals. This was the talk. So let's wrap up all the things said today. The first thing is that the token exchange feature is the glue between different authentication providers. The second thing is that DEX is lightweight, and it can be used to add only this capability to Kubernetes clusters with literally no overhead. So because this is lightweight, this is not a fully featured provider, and you will not see the DEX working here in your cluster. Okay, the third thing is that not only DEX benefits from it, yet the whole ecosystem. So because as I showed you before, DEX now can connect different projects of our cloud native environments to work together, which is pretty cool. And the final thing is that if security features are convenient to use, it will improve security in the world in general, because security now, it's not only necessity, but also like a popular thing. So if popular things are convenient to use, everyone will use them. Yeah, it was my talk. Thank you so much. Let's go to authenticate them all. Thank you. Thank you.
Yep. Thank you very much, Maxim, for your great talk. And we have some minutes left of your time. So if you guys have some questions, it's a good time for a Q&A.
Thank you for your talk. I was wondering, do you have an example for accessing a Kubernetes API through DEX in like a CI environment, like the first example? Can you repeat the question? So the question is, do we have an example how people can access Kubernetes API through CI/CD, as I have showed you before? Probably you need an example of kubeconfig, or what? So you need the DEX configuration. For now, we do not have this example, but there are people that already do so. So I think we probably can ask them to provide us to share the example. So yeah, this is a good question. Please.
So you mentioned in your talk configuring Kubernetes cluster to use DEX as identity provider. How that works in a managed Kubernetes in a cloud, AKS, GKE, EKS?
How we can connect an OpenID Connect provider to a managed Kubernetes like AWS, GKE, and something like this. So in most major providers, you can do so. I know that in EKS and in GCE, there is a special like interface, a web form. You may fill it, and then your cluster will work with your OpenID Connect provider. There were some issues in AKS in Azure, but it's also possible probably. And in some minor providers, like for example in OVH, it's also possible. But you need to check this feature. That's it. So what is stored in the persistent layer of DEX? We usually store there our authentication codes. So for example, when your user authenticates in DEX, you need to persist the data between the login and the redirect from the another provider to DEX back. So it's only for a short moment, but you need to store this data. There are also things like, for example, connectors. So you don't need to define your connectors in the config file. You can store connectors in the database. It's also possible. You can do this via API, also convenient thing. And DEX also stores the refresh tokens in this storage, for example. So it keeps the offline session there for sessions. And that's pretty much it. There are a couple of more tables, but they're not that relevant.
Any more questions?
So yeah, thank you so much for the questions.
Yes, also thank you. So, and also we now have like a little bit more than 5 minutes time for the next talk. also the other speaker. I haven't seen him yet, so see you in 5 minutes. Okay, so after having a first security talk, we will hand over to the next security talk by Mike Coleman. I hope you enjoy. You feel free to start.
I hope you enjoy it as well. I'm not going to use the microphone. Oh, geez. The Spanish phrase I like that I learned from my sister-in-law was "no pasa nada." It's all good, man. Doesn't matter. Anyway, my name is Mike. I am a developer advocate at a security company called Sysdig. We do cloud and cloud-native open source security. We are the company that donated Falco to the open source, or to the CNCF. Falco recently graduated, so like 2 weeks ago for us. So that was awesome. So I've been in about 9 years in the cloud-native space. I was at Docker in about 2014, 2015. And then from there I went to AWS. I spent some time at Google, and now I'm over at Sysdig. And then before that I was at VMware, where I was doing virtualization stuff. So I've been in virtualization containers for like about 15 years. If you want to follow me, I'm Mike G. Coleman everywhere. Because we got the thing, yeah. I recall Central Park. I cannot pick up a microphone without singing. Anyway. So this is, we're going to go through and we're going to talk a little bit about the cloud-native security landscape. This was basically born out of my own confusion, and I figured if I was confused, other people were confused as well. So we'll take a look at the landscape, we'll talk about what a CNAP is, and then we'll kind of map that to open source software. So the objective here is not to teach you how to use these tools, it's just so you know what they are. Right, and I said, I'll explain like why I thought this was an interesting talk. We're going to talk about a bunch of different tools. Some of the tools can be in multiple categories. Falco is one of those tools. Most cases, I'll just mention them one time, but they have other applications. And this is far, far, far from a comprehensive list. Right, I'm going to talk about like 9 or 10 projects out of the 100 or so that are listed on the landscape slide. So the reason I did this was, what? Oh my. One moment, please. Okay, so hopefully that comes back. The reason I did this talk was, if you think about cloud-native applications and securing cloud-native, you're securing across all kinds of different things, right? You've got, cloud services like buckets and databases. You've got identity and access management. You have got whatever platform you're running on, whether that's serverless or virtual machines or Kubernetes. You've got all your network policies. There's like about 15 different levels of security in cloud native in general, right? And we do all kinds of really interesting things where we make mistakes. How many of you, and I will only ask you questions where the answer is yes for me, how many of you have ever over-provisioned like a security account, a service account or something? Like S3 full access, right? How many's ever, right, when you shouldn't? I've done that. Corey Quinn, who has 100,000 followers, pointed out to everybody on Twitter that I did it, so that was nice of him. How many of you ever pushed AWS secret key up to GitHub? Nobody else. Someone's lying in this room. Or in Azure or Google. Anyway, how many of you push credentials up to GitHub in a public repository, right? So there's all these areas where you can just make a mistake. Right? So you think, okay, well, there's got to be a lot of things that can help me with that. So then you go to CNCF and you're like, they know everything about cloud native, so let's look at the security. Oh, wow. Wow. There's a lot of stuff on there. There's something called Claire. Does anybody know what Claire does? I don't pick Claire. I'm not picking on Claire. I just don't know. Oh, what? Thank you very much. You've got the magic power. Anyway, there's all these things on here, right? So then you're like, okay, well, I'm going to go and get some Armo. I'm going to put that together with some Outside and some Orca. And right, it's just really confusing. When you think about 15 different things you've got to secure, and you think about 100 different products, that's why I wrote this talk, right? It was just to kind of map it into and talk about some of the things. And we're going to do that in the framework of what's called a CNAP, which is a cloud-native application protection platform. And that's something that like we sell, and a bunch of companies sell these CNAP platforms, but it's not really about that. It's just to give a framework to think about what are the things you need to do when you go and look at a full spectrum of cloud native security, right? So the first one, actually, I'm not going to spend a lot of time on this slide because this deck was written for 40 minutes and I have 30. So we're going to skip this slide because we break down each of these in general. So the first one we're going to talk about is cloud native security or cloud security posture management. And this is how you protect the cloud in general, right? How do you set network policies? How do you set well, IAM actually comes in somewhere, but it's all of the stuff that runs in the cloud and how you protect that. So that's cloud security posture management. There is another piece to it called Kubernetes security posture management. We'll look at that. And why do you care about this? Well, we just talked about a misconfigured S3 bucket, but one simple mistake, right, can be devastating for companies. And S3 buckets are one of the most common problems that people have, making those mistakes, right? So anyway, so that is why we have something like cloud security posture management to look things like over-provisioned IAM accounts, bad network policies, public buckets, all of that sort of stuff. And then on the Kubernetes side, there's the same thing. It's sort of like, did you expose your API server to the world? Did you turn off the console? And those sort of things. So now so there is something like, a lot of times, it actually comes in the next one. I'll talk about it in the next slide. So when you think about that, there's a couple different ways to think about how you can start locking these environments down. So I've listed about 6 tools on this screen. So the first is, when we talk about Kubernetes security posture, how many of you have used KubeBench before? So a few of you, right? So KubeBench is basically, it uses the CIS benchmark. You run that against your clusters, and it lets you know if you're deploying them in accordance with, recognized best practices. So that's a tool that you can use as you're starting to set things up. And then another way to do it is, what's a question? Why do most mistakes happen? Habit, lazy, humans, right? It's humans. So when you look at something like Crossplane, and we'll talk about Terraform or OpenTofu, the use of infrastructure as code and to ensure that you're having repeatable processes so that you can start taking those so you can do one of two things. You can you can take them out, or you can repeat the same mistake 100 times, right? Because it's automated. Now you have automated mistakes. But the idea is hopefully you take care of that. So then when you start talking about actually running stuff in the cloud, there's these tools like Open Policy Agent and Kyverno and Gatekeeper, where you can start using those tools to instantiate policies. So we talk about like securing network layers. You can use these tools. So like OPA, you can go in and define a policy saying, look, you can't run this, you can't run this workload unless you have this label or some sort of factor on there. And that'll keep you from implementing things in your environment that don't work. And then that couples with Gatekeeper, which acts as an admission controller, saying, if you violate the policy, we're not going to let you run. And that'll keep you secure as you're rolling things out. As things get deployed, it'll block things that you shouldn't be running. Once they are running and somebody makes a mistake or changes something, that's where something like Falco comes in. So Falco is runtime security. So Falco runs by intercepting system calls in the kernel, and it looks for violations of things. So if somebody shells into a running container, Falco will write you an alert on that. So you do everything right and you deploy something securely, and then somebody takes a shortcut or they're lazy, right? Falco helps detect that sort of behavior and those sort of analysis. So this one is a weird one. So cloud identity infrastructure entitlement management. This is all about IAM and access and excessive permissions. And the reason I say this one is kind of weird is that I haven't found a lot of great open source tools for this, because so much of this is cloud vendor dependent, right? It's not generic. It's like it's different on AWS than it is on Azure. So there are some things you can do in this realm, but this is really one where, like, from an open source perspective, it's a little bit more difficult.
Did you attend the previous session?
Attend what?
The previous session?
The DEX one?
Yes.
I did, but I was working on my slides, so I didn't follow it very well, if I'm being honest. I'm not going to lie. I was not paying much attention. But Dex will help with that? Is that okay? There we go. Maybe will. So we talked about this a little bit, right? 90% of granted permissions are not used. So I mentioned that thing about the S3 bucket. I did that because I was using a plugin, And it said, just give it full access, right? And then when someone said, well, this doesn't work, how did I figure out how to make it work? I had to go, like S3 has like 53 permissions on it. I literally had to go through and turn them off and on one by one to figure out how to get the base level of permissions. And so it's just way easier. So you can call it lazy. I call it optimized, because I'm optimizing my time. But yeah, so this idea of being able to go through and audit those sort of things is pretty important. So some things in that sort of space about access and entitlement management, there's Keycloak. Anybody using Keycloak? So that's single sign-on, basically open source single sign-on to help you with that. When you have, and then there's a talk on this, I think the next talk's on observability by Tiffany, I think, actually. So she may cover some of this, but this idea of using tools like Prometheus, Loki, and Grafana, which are, they gather metrics, they display them, they aggregate them for you, where you can start looking for patterns in these environments. And then the same thing that we talked about a little bit with Crossplane is the idea of using Terraform or OpenTofu or Pulumi to roll these resources out so that once you have it defined, you have a known set of templates that you can say, look, this is how we define these type of roles, this type of access. So it's not really about detecting it, but it's more about preventing it from happening. So the next one is cloud workload protection. And this is, how do I know that the stuff that I'm running is secure? And this is one actually where there's a lot of really interesting open source technology that can help you here, right? So I actually feel like this is the area where we're the strongest in open source. And this is about like container vulnerabilities. 87% of container images have higher critical vulnerabilities. Is that a good thing or a bad thing?
More vulnerabilities, yeah.
Exactly, yes. It depends, which is the most people will like, if you tell somebody it depends, they think it's a cop-out, but it's really almost always the right answer. Right, if I have 101 vulnerabilities, but I'm not using any of the packages, then I don't care, right? It doesn't matter. But people get freaked out about that, and there are reasons to be. But there's also this idea of bloat and just using too much of an image. So if you look at something like Ubuntu versus Alpine and the size of the image, and most folks are out there running on sort of mainstream distros, which include a bunch of stuff they probably don't need. And then, there's all kinds of different stuff out there, right? So the crypto mining and all of that seems to be like, has anybody encountered that in the real world? A hijacked payload with crypto mining? Because it's like you have, I know it happens. It just seems to be like one of the canonical things we talk about. Anyway, so how can you do this, right? So you can use something like Sneak. And during your development processes, you can scan for vulnerabilities and you can keep them from entering, right? So shifting as far left, right? And then you move to the next step. Once you have them scanned and you know they're good and if you've locked some of this stuff out, you can store them up in Harbor. Harbor is an artifact registry that has signing and scanning so that if you scanned it, you didn't find anything, but then a vulnerability is introduced later, you will know that it's there. What's that?
Introduced or discovered?
Yeah. Sorry. I'm hard of hearing, and then like a little bit. I do have my hearing aids in today, though. Anyway, so yes. And it's the same thing that we sort of talked about with Falco, which is this idea of like what you put into production on Tuesday, it might not be what's running on Wednesday. And that's sort of the whole idea of like scanning and runtime security and why you have to do it across the spectrum of the environment. And then SigStore, which is about signing and verification of artifacts. So we actually use SigStore cosign on the Falco project to sign all of our artifacts so that you know that they're coming from, it's a French word, provenance. Yes, right? So that you know that what you're running is what you think it's running and it came from who you thought it came from. And then that last slide about like, the bloat and the images and the CVEs, there's a great distro-less container image from ChainGuard called Wolfie, which basically ChainGuard has spent a lot of time and a lot of effort putting together a bunch of images to reduce the CVE count. So like, yes, if you have 100 CVEs, you don't care if you're not running them, but it's still better to have 0. right? Because you don't know what's going to come out the next day. You don't know when you might start using something. So that is an interesting option in that space. So the next one we're going to talk about is cloud detection and response, and that kind of goes across the whole spectrum. And of course, on this one, I can spend a lot of time talking about this one. This is basically, how many know, was it Neo4j? I think it's Neo4j. Who knows how long from the time that vulnerability was introduced to when it was exploited? 10 years. Right, so I talk about like what you're running on Tuesday isn't what you're running on Wednesday, but this is something that took 10 years to figure out. This was all out there, right? Based on research, right, 270 days to identify and 70 days to contain a breach. Does anybody know what the mean time to pain is on a breach? Mean time to pain is like as soon as when they start causing you problems. It's about 10 minutes. Right, so when an attacker has access to your system, the research that we have from Sysdig says it takes them about 10 minutes to start doing things that you're just not going to be happy about. And that's where tools like Falco and Tetragon can come in. So these are runtime security tools, and they actually run the gamut of what they can actually do, because they can look for things like, are you running bad versions of the binaries, or they can look for things like, you pushed secret keys up to GitHub. Falco has a plugin architecture that lets you basically, I did a talk at a security conference in Canada last year called Nearly Universal Threat Detection with Falco, because Falco has a plugin architecture, and if you have a stream of events, you can build rules on that. So you can, like, one of the guys at work, Thomas, he just built one for Bitcoin. Like, so he monitors, like, there's a stream of events coming off a Bitcoin ledger, and he monitors those, and you can build a rule, right? Has anybody done a Bitcoin transaction worth over $10 million, right? Or, more practically, has anybody pushed something up to GitHub that contains the phrase AWS secret in it? Or, more relevant to what we're talking about today, that sort of thing. And then, so that's, with Falco and Tetragon, we can be looking at what's happening in those systems in real time as they're put into production. And a lot of time, we spend a lot of time thinking about that sort of front end stuff, or at least what I've seen people talking about the front end part of it, which is like, let's scan for vulnerabilities, let's we'll scan on the developer desktop, we'll scan in the registry, we'll make sure that we always know what's happened, and then we put it into production, and then once it's running, we don't know what's going on. We're not really, we know what's going on from like an application performance standpoint, but from a security standpoint, like, how many of you run Kubernetes in production? How many of you would get an alert if somebody shelled into a running container? How many of you are running Falco to do that? What are you guys using for? How are you doing it? Are you using Falco or not using Falco? Okay. What's that? Yeah. So that idea of like, so there was two people that said, how many were running in production? Do it again. Almost everybody. How many of you would know that if someone shelled into a running container? How many of you would agree that shelling into a container and doing something is an operational anti-pattern that can cause a security hole? Right? So that's the thing, right? We have all these ideas of like, oh, we shouldn't do this or that with containers, but we have no way of detecting it. And that's where Falco comes in, and Tetragon as well. I can't speak to Tetragon nearly as much as I can to Falco, because Falco is where I spend 90% of my time. But Tetragon offers similar functionality. I will actually say Tetragon, from what I understand about it, offers some functionality that Falco doesn't, because this is not America, but let's see if it works in America. If it works in Europe. If I say peanut butter, what's the next word? Jelly, right? And so this is cloud detection and a response, and Falco does not do response. It does detection. Tetragon actually has a response component. We have a nascent project called Talon, which will allow us to do some remedial response on common things. We also have a companion project called Sidekick, which allows you to build out response engines. But anyway, that's enough talk on Falco. So, and I wanted to finish in 25 minutes, and I did. That's why I cut out 10 slides. So anyway, the takeaways, right? So obviously, this was just like a quick overview of some key projects. I tried to hit all the ones that were either incubated or graduated to give you an overview of that. the general idea, right? There's a big area out there. I think we spend a lot of time thinking about certain buckets, and we don't spend as much time thinking about other ones. And that's why you need to like kind of look at it, not just, you know, scanning and protecting and network policies, but all the way through from the moment the developer deploys it to the moment you retire that container. All that has to be considered. And I think that sometimes folks don't think that way. I wouldn't say go out and try to do all of this at one time. You know, pick it up as you want, and then always focus. Like, we didn't even get into like this idea of like zero trust and least. We talked a little bit about kind of least privilege-esque, but there's a whole bunch of other stuff out there, you know, that you should be looking at as well that kind of wasn't covered today. This was not designed to be like fully comprehensive in that way. So, 5 minutes left for questions. No questions mean I gave a perfect presentation. Oh man, I did not give a perfect presentation.
You did not mention S-bomb. Can you maybe?
Yeah, I didn't talk about S-bombs or salsa or some of that stuff. Yeah, so those are the idea of understanding software bill of materials. And I can never remember what salsa stands for, but it's the idea of understanding the components and documenting them and putting them in and being able to replicate them. Do you do stuff with that today? No. Okay. I didn't know if you had. I was basically asking if you had like personal experience you would like to share. Okay. Anybody else?
Yeah. So the runtime part of this. It seems like a lot of projects are focusing more on container image scanning, code performance, everything on the supply chain side.
Yep.
But like the traditional security vendors who, have always focused on endpoint protection. They have virus scanners and malware scanners for Linux servers and for desktops and all that stuff. You see them doing a play for the container space now as well. How is that landscape evolving? Are we seeing more open source projects around endpoint protection, stuff running, at the runtime side of container execution, or?
Yeah, I mean, I think it depends on how you we don't. With our, so, I gotta go. I thought maybe they figured out which passport I used to come into the EU this time. And actually, I have Spanish citizenship and U.S. citizenship, so it's not, I'm a criminal. Anyway, so if you think about containers and the way they live and the way they die, I don't know how much of that endpoint stuff comes in, like virus scanning and whatnot. At Sysdig, we don't do a lot of that. We do focus on the runtime stuff, which is more about the behavior. But your first part of what you said was, folks tend to focus all on everything that happens until it starts running, and then they forget about it. And I think that people live with a false sense of security around the fact that containers are immutable and they're short-lived, and that, what's the worst thing that can happen if it's running for 5 minutes? Well, a lot of things can happen if it's running for 5. So I do feel like in that space, if you care about analysts and Forrester and Gartner, most of them will tell you that if you're looking at full protection, that runtime has to be a part of that, and not necessarily endpoint, but the idea of understanding how the containers are being operated and how they're being, what's happening with them until they get retired out. In the back.
I hope this cable will manage. Even better.
Yeah, so you mentioned sort of having less in a container, so like potentially distro lists and things like that. But there are things like WASM and potentially things like Kata containers, which also give a good sort of option there. But how do you sort of see the observability side of that? Because lots of the observability tools aren't as good when you start running things inside a more complex runtime like WASM. So do you see any answers for that kind of thing?
I mean, I don't. I know that there's a talk on observability. It's either going on right now or it's right around. I think Tiffany's going to come in and talk about observability next, so she might have some insight into that. But I think that if you ask that question in 7 years, right? Because if you think about where we're at with containers, we're about 7 years on, and WASM, I feel like 2 to 3 years, kind of where we're at with WASM. I think that we didn't know the problems we were going to have with containers 8 years ago, right? And I think that's where we're at with WASM and some of that stuff. So, and observability is not my strong suit. So what I can just talk about, like from a maturization and how software gets written, when we start getting critical mass and that stuff gets picked up, I think that'll be interesting. They did have, WASM.io was this week too, but I don't know where it was. It was on Twitter. Barcelona? Man, that's where I was born, Barcelona. There you go. I should learn WASM so I could go. All right, we are at time. I want to thank everybody for coming out and hanging out with me today. And if you have other questions, I'll be around. But thanks for Rejekts for having me, and thanks to all the sponsors, because this is a fantastic event.
Yeah, thank you, Mike, for this fantastic talk. So now we have a 5 to 10 minutes break until the next talk starts, and we are waiting for Tiffany and for Matthias to actually the observability talk, which is going to happen here at 10:40. So be prepared. So, after two very interesting security talks, we make now a shift to observability. And I'm very welcome to present you Tiffany and Matthias for the next talk. So enjoy.
Hello, can you hear? Okay, need to get used to that mic thing. Yeah, good morning, everyone. Thanks for coming to our talk. I think there was just a talk about like the overview of the security landscape in the CNCF, and now we want to continue that to give a bit of an overview of the observability landscape. Before we dive in, just a quick introduction to ourselves. You want to start? No, should okay. Okay, I'll start then. Normally we do ladies first, but we're going to change that today. So my name is Matthias. I'm from Germany, not too far away. In Stuttgart, it's like the next closest city, so like only 4 hours by train. Very happy to be here. This is my first Rejekts, and I have to cut this short because we only have like about 30 minutes to do this, and I give it back to you.
And yesterday you said it was 3 hours. I don't believe you anymore. Anyway, yeah, I'm Tiffany. If you want to know a bunch more stuff about me and a bunch of talks I'm doing, you can just go to my website, tiffanyfay.dev, and then that's my Twitter and LinkedIn. So, yeah. Okay, so this is a 30-minute talk. If you feel like afterwards you still want to listen to us for like 3 hours, here's a deep dive that we did at Devox, so you can take a look at that. Okay, so question is, all right, so one, why are you here? And why do you care about observability? So hopefully the need for observability is pretty clear. If you've worked with Kubernetes before, which I assume most people attending this have, you probably found it pretty complex in the beginning, and they're trying to understand everything that is going on there. So basically in this talk we're going to go and like show different tools and things that can help make your life easier. So like why can it be such a problem when we have Kubernetes and a bunch of other things? So basically there's just like a certain level of complexity that we have. So over to the right, you can see that we have a bunch of different containers that you have. These could be various like polyglot different languages, you could have different frameworks, and being able to know more about just like what's specifically happening there, but not just between like with the individual applications, but also what's happening between the different applications. Then there's also all of the Kubernetes API objects that you need to at least have some understanding of and that you have to worry about too. Then we also have so we have the app level, and then we also have the infrastructure. So there's the control plane, and then depending on how you're running that, what you may be able to see there. And then you have your worker nodes, which is where your applications are running. So like in short, basically there's a lot of things there that you need to be able to like know about or try to figure out what's going wrong. So that makes observing Kubernetes kind of complicated. So basically there are a bunch of different places where you can have introspection. So basically it depends on like what level of metrics that you might want. Like so for instance, we might have our application, you can do specific things there. Your application is then running in a container, which runs in a pod, and that runs on a node. So at every single one of these points, you could be able to do some introspection. There's also, you have your API server and then also your infrastructure as well. And it's basically like a trade-off of like, what do you specifically need? So maybe there's things that you have to deal with like overhead and configuration costs and just kind of figuring out, balancing what you need versus what you have to give to do that. So basically there are a bunch of tools out there that help, that you don't have to necessarily go and build all of this yourself, which is really great. However, this is a slightly outdated screenshot. Apparently it now scrolls the other way, but basically trying to figure out everything that is happening here, there's a lot. We are not going to obviously go into all of this. I don't even know how many days or weeks or months this would take. But basically if we take a look a little deeper, we can see that there's stuff that's specifically there for like monitoring, logging, tracing, etc., that help in the space of observability. And so we're going to touch upon a few of those based on things that are there, like that we have used in the CNCF landscape, basically, and open source in general.
All right, thank you. So the way we're going to do this, we start with like the simplest form, or basically coming from the outside and going further in on the cluster. So I'm going to start talking a little bit about Kubernetes API-based tooling, which is like the highest level form of introspecting things happening into your cluster. Then, as Tiffany showed, there are various levels, how you can get like closer to what's happening inside. We're going to go on to pod-based and node-based monitoring, and in the end, finally close things up with the application-based stuff. So yeah, the API-based component is actually when you would place your agent connecting to the Kubernetes API and try to query the information from there and see how far it can give you in terms of help. Now, when people get started with Kubernetes, probably the first thing they're going to interact with is the Kubernetes, the kubectl API. And you already have some high-level information with commands like get, describe, and logs, where you can find out what is the individual state of your components. Do you see certain events which are not looking right? And get a higher-level feeling of what is going right or wrong. There's also things like debug and exec, where you can actually start interacting with the components and query things deeper. Now, also on that level, you have a certain form of tools. They kind of normally separate into 3 categories. You have the CLI-based ones, you have like web-based ones, and you also have some kind of fat clients. Also, in addition to what Tiffany already pointed out, what brings the complexity into observing Kubernetes is not only the various kind of different components that you can look into, it's also kind of the changing landscape of tooling that you have. I've been talking about this topic for a while, and when I did my very first talk about that, I was pointing out to tools like VMware Octant, weaveworks Scope, Lens, and so on. And over time, I realized things are changing here. So open source projects get abandoned or not continued. Things turn commercial. And then we pointed out there's K9s, which has always been our good open source friend, stayed with us, and we're certainly going to highlight this one. But new things come in, so the landscape is changing. People from Headlamp and Schooner would probably object and say they're not new kids anymore, which is about which is about right. But still, as opposed to the others, they are on that landscape. They still do the thing. And I just want to give an overview of what's happening here. Now, as said, 30 minutes won't be enough to live demo all that. If you are interested in any of those things, please feel free to see us later. I have an environment running where I can show individual pieces of those components, but for now, screenshots will have to do. So this is K9s. Most of you have probably seen this. It's just like an aggregated form, all command line based, which is very often helpful if you don't have like a window environment. So if you only have a shell, this will always come in handy. You can also list and sort your resources, have a quick observation if things are going right or wrong, and can drill down into the details from there. Now this is old Octant and Lens, so we're going to go over these. In general, if you know one of those tools and what they can do, you kind of know what they all can do. They don't like extend the functionality of what your Kubernetes cluster can do anyways. It's just like they give some nice navigation, especially when people start learning Kubernetes. This can be very helpful when they get flooded with all the new API objects and what do they all mean. So you get like sorting, aggregation, nice visualization. You can figure out if things are failing, restarting, are exhausted, and so on, and can go in there deeper. One of the things that I wanted to point out here quickly is that debug functionality. It's not super new anymore. It's like I think came in with API version 123. But it's still very helpful if you're like in troubleshooting or diagnosing. What it actually does, it attaches the binaries of a container to the running container in your pod. So it's not like a sidecar, which runs things in a different process, but you load all the binaries and can execute it from there. So this can be very helpful if you have like a distro-less container or something like, or if you're missing some diagnosis tools in your container environment, then you can simply load it into. I mean, it is as dangerous as it sounds, so you should not enable this by default. But when you're in such a situation that you have like a failing application and you still want to query some things while it is still alive, this can certainly be a big help there. So to wrap things up on the entry-level side, so the API tools do not need any change in the cluster or application. So you can just use them as they are. Query the stuff that your API allows you anyway, so it's completely non-intrusive. It's also very helpful for getting started with Kubernetes or getting a quick overview. But with that, of course, it also has limitations. So even though the tools might show all your pods healthy and running, it still might be the case that they're not talking to each other and things are not working well, or you have some ghosts and so on. And you wouldn't be able to find it out just with that. So to get there, you probably have to go a level deeper. Before we go a level deeper, I just wanted to have one quick word about Prometheus and Grafana, because this slide was actually initially not in there, but people just told us you cannot speak about observability without mentioning Prometheus and Grafana, which is about right. Anyone in here not familiar with Prometheus and Grafana? Okay, I would have thought so. So we can go over this. I mean, later on, Prometheus and Grafana, of course, not like stand-alone observability solutions, but it's like you have the data store and you have the customization dashboard that you can use. And we will later on have references of tools exploiting the functionality of Prometheus and Grafana, but we're not going to demo it out here as such. So with that, I'm going to give it to Tiffany for the next level on a, let's say, pod-based kind of monitoring.
I'm still not used to this whole passing the mic thing. It's kind of cool. All right, so yeah, pod-based, and then like specifically going into service mesh. All right, so basically earlier, like we saw just kind of like a high level of like all the different places that we can look at. So this specifically, again, is at the pod. So like basically what you have is you have like your application that's running in your pod, and then you also end up having what, like you mentioned earlier with the sidecar, but having a sidecar where you can do some sort of observability over there. So using that to be able to collect metrics specifically at this level. So if we just take like a quick look over this, so this is just like having one application running, and that is this container is connected to the network traffic. So within this pod, you can have multiple containers running. It doesn't make too much sense to have two different applications that are going on in there. Instead, since both of the containers or whatever containers you have inside of a pod, they're all connected to the same network traffic. So basically, this sidecar or proxy basically can go and see everything that's happening that your application can also see and collect data based on that, with basically get network data and listen on that. So it's not super useful if you just have it for one specific pod. It makes a lot more sense to have it for every single pod that you have running. So that way you can get all the information for the network that's happening on for all the apps that you have running. So basically you have your control plane, which is going to go and collect all this information from what is running on your data plane. So you can see things like how long does a specific trip take, and just like if you only, again, have just a proxy in one, there's only so much information that you can specifically get. You can apply rules, etc., and just do things based on that. So one of the really nice things is it is independent of whatever language or framework you end up using. Basically, it's running separately from your application, so you could use Go, you could use Java, etc. You could use different frameworks inside of the same language. It doesn't matter. But based on the fact that it is running separately, you can't get app-level metrics specifically from this, but you can get all of the network metrics instead. So it kind of limits the depth of like what you can see, but the fact that it's separate makes it pretty nice. And because of that, you can also be like, okay, well, I tried this out. This isn't for me. I don't want to do this. And then you can just go and pull out those sidecars. You don't have to go and rebuild your applications. It will restart your pod, but that's not too bad compared to having to rebuild your entire application and push that back up. So then all of this goes and just like feeds into the control plane that collects all of that specific data. So this is a diagram specifically from Kiali using Istio. So like the fact that you have all these metrics, sometimes depending on who you are, you may not want to just look at a bunch of numbers and try figuring that out and see what's connecting. So being able to visualize that helps a lot. Like with Kiali, you can see things like percentage breakdown of split between different versions. You can see the direction that traffic is flowing. And this is just like for a simple like to-do list that Matthias had created, but basically
Best thing I've ever done.
So yeah, basically it just like helps you get a lot more visibility into what is happening, whether something is like, if it ends up being red, for instance, or I guess he's partially colorblind, hence the purple Kubernetes logos on some of the slides, but depending, it may or may not be useful. But it's a lot more useful as your application gets more complicated, trying to figure out what is happening. Like for instance, we can see that on this one, something wasn't set up with wavefront proxy, and therefore all the traffic is red. So just being able to look into these different types of things. So just kind of to give a little overview of this, basically it extends Kubernetes for limitations in like things like traffic awareness or shaping. Like for instance, if you have bunch of, like, 5 replicas of your pod for a deployment. Like, it would be split evenly over that. But if you're like, hey, I want 30% on this and 20% on this, et cetera, you can use service mesh to help you with that. And then you have the concept of having like a sidecar proxy that is injected into every single pod that you have. When you first start up, you maybe want to manually do that, but you can set up so that every new pod ends up doing that. You can't get application level metrics. That's stuff that we'll look into a bit later. And then you can make changes during runtime instead of having to rebuild something as well. So the next part that we're going to look into is on the side of node-based instead of pod-based. eBPF is one of the ways of going about doing this. It isn't the only one. So basically, instead of having your agents on every single one of your pods, you basically have an agent that is sitting on every single one of your nodes and observing from that. Oh no. Hi. Isovalent in the crowd. All right, so eBPF stands for Extended Berkeley Packet Filter, which is probably why they shortened it to eBPF, because that's a lot of words. So basically, like, it's a pretty low-level functionality. So like we're actually like going and looking into like Linux things and into like the kernel space. So the kernel space is where your kernel software runs. Usually this is a pretty protected environment so that you can't just accidentally mess things up. If you wanted to try contributing something to Linux, it might take you quite a while, maybe a few years to get something there, but that's not really going to work at the iterations that you would want to be doing with something in the observability realm or just like changes in general. So like you can kind of view it in a way, kind of like JavaScript running in a web page. You have code running, you can do things with it, but you aren't like damaging any of the underlying infrastructure. That's basically what the eBPF sandbox is in the kernel. So basically, yeah, you can run custom code, can't harm the environment with that. And basically, since the kernel space can interact with like kernel events, such as like network events, and then you have the side over on the user space that you have like your SDK, your libraries and tools that you can do things with that. If you want to see a bunch more stuff and like really diving into things, yesterday James had a talk that is up on the stream, so look into that because we are not diving into that level. It's really cool. Okay, so I mean there is like so most of the time basically with containers, the majority of them are using Linux, and so basically. We have like various layers. We have the operating system, you have a container daemon. On top of you basically have your containers. So like with the fact that it's like a low-level Linux technology, we can use that to our advantage and basically get more information from the kernel from doing that. So this looks kind of similar to the diagram that you saw earlier, but so we have our control plane, which is again collecting all of the data. And then afterward, at the bottom part with your data plane, basically you have your nodes, and then you have each of your agents and having that specifically on each of your nodes. Ideally, you have more pods than nodes. If not, please tell me why. I'm a little concerned. So that's just one way of looking at it. So this is a diagram that's specifically from Hubble UI, and this is with Cilium. So basically, it's kind of similar. Basically, you can see this is for, I think, yeah, this is also for pet clinics. So the other second diagram that we saw earlier, you can see how the direction of the traffic and different things that are connecting. What you don't specifically get from this dashboard, unless this has changed since we took this screenshot, is that you can't see things like response times and throughput, but Cilium does have all of these things. So you can actually, for instance, go and look at this data using Grafana and be able to like see those specific things that you couldn't in the other diagram. And so you can see things like how long does a call take, for instance, and then like a tracing breakdown as well. And like we've mostly been talking about like open source things, but Cilium has like an open source core, and there's also like a licensed version as well. Not really sure where the separation is, but yeah. So as eBPF is becoming more and more of a talked about topic, there's a bunch of other things that are coming out as well. So there's things like Pixie, there's dflow, there's KubeShark. You can see different like levels of like tracing or how things are connecting. If you want to look at a bunch of the other applications, you can go to ebpf.io/applications, and there's just like a bunch of different things there. Some of them were talked about yesterday, like Inspector Gadget, etc.
I think there will be an eBPF day tomorrow. So if you want to know more about those tools and get a better overview, I think this would be the place to go. We can only like scratch it on the surface here.
I've never held a mic for someone before. Okay, so just a high level on this side of things, basically you are injecting your proxy component on the node level instead of on your pod level. Since you have fewer hops, there's less latency. It's using a low-level functionality basically for Linux that's leveraged specifically for Kubernetes purposes in this case, and then it's like changing pretty rapidly. There's a bunch of stuff coming out, even just compared to like a year ago. There's so much more that is out there now. So I'm going to pass it back over to Matthias.
All right, thanks a lot. All right, so to sum things up until here, we've kind of seen on an entry level how with the Kubernetes API we are able to, for example, like sense if there are any kind of problems or there might be some certain problems in your landscape. And with the help of like service mesh functionality, be it pod-based or node-based, we're now able to like see the traffic flow between those components. So we also can already go into an isolation level of our problems, but we still cannot see into the applications as the components are, as I said, either running on the node or on the pod, but not within the application container. And for that, we basically come to the final part, monitoring within the application itself. Unfortunately, it's not as simple as it looks here on the slide, just putting that little agent into the app. But generally, this is how it works. So of course, then the metrics are being collected, and there are various ways to visualize that to the observability end users. Now, the problem with that landscape is as well, there is a lot of different toolings that will plug into application and provide different deep level tracing and metrics collection. One of the things to highlight in this context is certainly OpenTelemetry. I think this one is one of the tools in the CNCF landscape which was like, I think, second one after Kubernetes with the highest commits. Please tell me if I'm wrong, but this is what I just heard recently. And it's also one that's showing a positive tendency, in my opinion, while on other areas the landscape is more and more spreading out, and you have like very many different solutions that you have to select from. OpenTelemetry is actually like merging things together from different solutions. So the way it works on high level, I should probably say it's not like a full observability solution with dashboard and everything. It's focusing on the side of standardizing the collection of the information. So in the past, many vendors had like proprietary formats of how they collect their like tracing metrics and log information, and OpenTelemetry tries to standardize that to give a lot of parties the chance to integrate into that system, and especially with the application landscapes becoming much more polyglot, being able to correlate all the collected stuff across the different components. So we're going to look a little bit into what is currently out there for application collection, and the way you can actually start doing that. Now, so far, everything in the talk has been totally application framework agnostic because we did not go into the application itself. Once you start monitoring from inside of the application, of course, your agent has to be specific to that implementation language. So a little disclaimer, the next couple of examples are more Java-based than others, but still there is a lot of different agents for various implementation languages out there. So with the Java part, the least intrusive way to actually get there is to plug the OpenTelemetry agent into your Docker container, or into your container. You do that by adding it to your Docker file and then hook it into the Java command. This has the advantage that you don't have to actually rebuild your jar file, and you only need to rebuild your container. Anyway, either way, it's a higher level of intrusion as what we've seen before, because it's not only requiring a restart, but a rebuild activity. After that, you of course need to configure that part in basically telling where to send the metrics to, in this case like the OpenTelemetry collector, and from then on it can be kind of aggregated and correlated with other things. Of course, you can do it in a different way to really plug it into your application infrastructure, basically modifying dependencies and pull in the OpenTelemetry collector there. From there, it's kind of the same procedure. You also have to basically take the information and send it to the collector. So you see there are various ways of collecting data into OpenTelemetry, and then things kind of getting stitched together there. And then you, of course, start getting application-level metrics. So again, this is a Java example, collecting metrics and visualizing them in a custom Grafana dashboard. And now you're seeing like Java garbage collection, heap information, things like that. And this is something you would not get with any kind of service mesh implementation, at least not to what I'm aware of by now. Jaeger is a technology I want to highlight here real quick. This has been there before OpenTelemetry, but it's certainly got a big push through OpenTelemetry because it can be used with that in a fairly easy way. But it was always already possible to use it with other technologies, for example, with Istio, as Tiffany said before. So here, you would see a Jaeger example. Sorry. How if you feed the information just from a service mesh Istio-based thing. So you only see the two services, and basically the outer trace and the inner span, when one service starts, hands over to the other and returns. So this is the entire information that you get from an outside perspective. Once you go further into that, you see the traces with the application-specific components. So you see like the REST endpoints when you hit the application. You see like the MVC pattern, then the database invocation. And it's very easy then to isolate or pinpoint which is your problematic component within your app. This can be done by a thing called auto-instrumentation or auto-SDK in OpenTelemetry. You don't have to do anything except putting the agent in, and you get the information out. However, if you have certain levels in your code that is not being auto-detected by the auto-instrumentation, you can still tell there are ways to talk to this SDK and say, okay, I want this method and this variable to be collected in my trace as well. In the Java world, you have the annotation, for example, with span and span attribute. By default, the original version of the code would be here. So you have a post mapping, you enter a string, and it would be saved to the database. I now rerouted that to a method that I called some useless method, because we don't really need to use it, which would just like not be like collected from the auto instrumentation. So then I annotated this, and once I did that, it then shows up in the traces as well. So this might come useful if you have an error which just like shows up sometimes and you don't know why it's happening, and then you can basically figure out and say, okay, this is the variable setting of that execution call that has caused the problem, and then isolate it further down. Yeah, I'm saying make a break soon. We're going to make a break soon, 3 minutes. So yeah. To sum it up here, this one, as I said, is not as simple as the previous solution because it is specific or limited to the implementations of various programming languages. But with that, in turn, you get all the details from inside. So this is kind of the price you have to pay to get to the level of this root cause analysis. Now, yeah, to sum things up, I hope we were able to give you a bit of like a categorization of where the various tools are falling into, what kind of level of information you can expect by paying how much of interaction with your cluster and your containers. Of course, this is the final thing I want to say. We don't know all of the solutions by heart in that landscape. So before I open the round for question, I also have a question for you, and that's like, from your experience, did we forget anything significant we should highlight here? Is there some, I mean, these are the ones that we are familiar with from projects, from our own experience, but of course it's hard to know them all. And with that, I think this is again the link to the 3-hour version of this talk. Will do the same stuff, but have all the live demos and setup and configuration included, so you have a lot of time. Feel free to watch it. I think with that, we can say thank you.
Thank you very much for your talk. I think we have still like 2 or 3 minutes for a few last questions if you want to ask. Anyone? Questions? Yeah, here.
One of the interesting projects I think that could be useful in auto-instrumenting code without changing it would be the continuous profiling stuff.
Yeah.
I'm curious, like, have you looked into that stuff at all, or?
So but basically injects the OpenTelemetry code into running applications.
More that it takes like a core file from what's actually happening, or continuously profiles the application using like kernel performance, and kind of looks at the way that the application is operating against the Linux kernel and the resources that it's using. So it can actually understand like where a particular function, like where in your code a particular function is taking a long time, like what you're actually doing for those sorts of things. The companies that are in this space are things like Polar Signals and.
Okay. Does it work across all kind of languages?
It does, and it's actually even getting more and more interesting because like Polar Signals, for example, is now able to like do a lot more discovery of functionality, like automatically discovering particular functions in Python programs, for example, like without any instrumentation in the code itself, which is wild to me, but like
okay,
it's a really interesting new space. Yeah.
Next iteration of the talk, we're going to have it. Thanks. Well, are there any questions too, or
any questions?
And a break.
Okay.
All right. Thanks.
Thank you very much. So we will keep on having observability-related talks from 11:30. That's a little bit less than 20 minutes. So grab a coffee, and we'll see you soon. Okay. After a break from our last observability talk, we now have another observability talk by Yuri and Urazi. And I hope I pronounced your name right. Yes. So welcome and enjoy building resilient observability pipelines.
Good morning, everyone. My name is Yuri, and I work at Red Hat at the operator enablement team. Yeah, I'm basically handling Kubernetes operator on a daily basis. So, thank you. But do you need microphone or it's for the recording? Okay, so let me repeat myself. So good morning everyone. My name is Yuri. I work at Red Hat. Yeah, I'm handling Kubernetes operating on a daily basis, and my friend here.
And I'm Jurasi. I'm a software engineer at Grafana Labs, and I work with the OpenTelemetry collector.
Oh yeah, thank you. And today, I'd like to invite you all to embark on a journey to understand how can we build a resilient observability pipeline, and using the OpenTelemetry collector. We're gonna cover in that journey some concepts like data persistence, scalability, instrumentation, high availability, and all of that, it's important in the end to detect our failures. To start that talk properly, let's understand what is exactly resilience in observability. I'd like to paraphrase a colleague in that sense that wrote, is the ability of an application to resist or recover from certain types of faults or load spikes and remain functional from the customer perspective. And now let's understand how the OpenTelemetry collector can help us, or not us, but our applications, to recover from certain type of faults.
Yeah, so what exactly is then a resiliency in the context of OpenTelemetry collector? And what is a pipeline when it comes to OpenTelemetry collector? So a pipeline can be either a configuration of a collector itself or a composition of OpenTelemetry collectors. So we can chain collectors together and get a deployment, and we can call that chain of collectors as an observability pipeline. Now, an OpenTelemetry collector pipeline, the simplest way, is just a configuration file like the ones that we are seeing here. So it's just a collection of receivers, processors, and exporters tied all together into what we call a pipeline in the configuration file. Now, what it means in practice is we have an application that is generating telemetry data, and that application sends data to a collector somewhere. That collector do some processing on that data and send data out to a backend. It can be a logs backend, it can be a metrics backend, or perhaps a tracing backend. Now, what happens when the collector is dead, when it dies, or when the connection between collectors and backends, they are not there anymore? So what happens when there is no telemetry data being sent to the backends? Now, in some situations, it might be fine to not have resiliency, to have data to not be sent. And tomorrow at the Observability Day, we're going to cover one of those topics. So for one company, it's fine for them not to have a resiliency or a HA or highly available collector deployment. Because a collector can restart very quickly, so they can afford to lose some data for some time. But for most people, it's not actually fine. And if it's not fine for you as well, then that's what we're going to cover in the next few slides as well.
Yeah, thank you, Jurasi, for mentioning that, because for some people in some environments, it's not fine to lose a OpenTelemetry collector in in the middle of an outage. And let's understand what is the path, right? Most of you may know the configuration or how a OpenTelemetry collector configuration looks like. With the receivers, processors, exporters, and scaling. And if we cover all that topic and we are going to dig into that configuration in order to achieve the resilience, because most of you already configured it like receivers, to receive the telemetry data, like logs, metrics, and traces, and processing that, and transmit it to the backend. But how can we turn it out resilient?
Now, when we start to think about resiliency in terms of receivers, the Big Bang was not the beginning, right? So the receivers are the beginning of the journey of the telemetry data. So we start getting data within our pipeline as part of receivers. Now, there are so many things that you can do with receivers to ensure that you have a resilient receiving side of your pipeline. And most of them are related to the resiliency of the connection itself. Right, so you should ensure that you can still receive data even if the remaining of your pipeline might be problematic. Now, when it comes to the networking between your receiver and your client, what you can do is you can do things like setting a maximum connection idle time for the connection, so that the connections are broken after some time, forcing the clients to build a new connection to the server, to the receivers. Now, when we are talking about gRPC, what it means is the client-side load balancing for the client side of those receivers, they would be forced to be refreshed. So they would get new connections to new collectors. So perhaps you have an elastic deployment of your collectors. So you have new instances of the collector. And those instances, if we're using gRPC, they're going to be idle for some time. So they're not going to get new connections until clients break their current connections and try to make new connections. Right, so we get better client-side load balancing when we force connections to be renewed, when we force closed connections. Now, this is just one example of the type of resiliency configuration that we can apply to receivers. And within the OpenTelemetry collector, most of the receivers that are passive or receiving data, they follow some common patterns, like the config gRPC and config HTTP. So I guess the point here is take a look at the configuration options that you have to tweak your receivers' configurations when it comes to networking.
At that point, we understood how the receivers work, and some strategy that we can use in our observability pipeline. Once the telemetry data reached the OpenTelemetry collector, the data should be started processed. And at that point, we have to configure the processors. We brought here two examples of processors, like the memory limiter and the batch processor. The names are really clear. The memory limiter will limit the memory amount that OpenTelemetry collector is using to ingest the data, and we could, to turn it out on observability pipeline more resilient, we have to limit this amount of memory, and also the batch processor, which we will split the telemetry data in batches, not in smaller batches, but in a batch with the proper size that your infrastructure is expecting. And it's important also to talk a little bit about the future of those memory limiters and batch processor. There is a perspective that memory limiter will be replaced from a processor to an extension. That is another concept of the OpenTelemetry collector. And the batch processors, instead of being used as a processor, will be a parameter of an exporter, okay, in the OpenTelemetry collector. I believe it's worth to mention that a little bit about the future perspective in those processors.
Yeah, But then we have also resiliency at the exporter side. And I think, to me, that's the most interesting part. Because that allows us to create mechanisms that allow our collector to be resilient to failures on the next hop. Right? So if the server we are or the backend that we're sending data to is offline or not reachable by our collectors, we can still keep data in memory and keep retrying to send that data periodically to the backend. So whenever the backend comes back online, we can send all of the data that we have in our queue. So there are two things that we can configure here. One is the queue size. So the bigger the queue size that we have, the more data that we are going to buffer in case of failures. And the other relevant option here for us is the type of the queue. So we can have, by default, we have a in-memory queue. So we store a queue of a certain size in memory. But then we can also make use of persistent queues. So using persistent queues, whenever data is not flowing to our backends, data is going to be persistent on disk. So if our collector crashes, then we can replay from disk. Or if we have a backend that is off for longer than just a few seconds, we can reduce our memory consumption by flushing that data onto disk. So we have a possibility of having bigger queue sizes there. Now, similarly to receivers, we can also have we have the possibility of making connection tweaks. So we have also config gRPC and config HTTP, while on the receiver side, we talk about server side. In here, they are the same constructs, but on the client side, right? So here we can force also some connection, some changes for the config gRPC so that the connections are refreshed and renewed. So our exporters have better client-side load balancing, but we can also work on some tweaks for better batching at the config HTTP.
So, receivers, processors, exporters, configuration. But, okay, you can approach me. We learned some parameters example, but, okay, Yuri, how can I detect failures of my OpenTelemetry collector? Because I can configure, I can tell to the OpenTelemetry how the data, the telemetry data will flow in and flowing out, but how can I detect exactly the failures? We brought here some, four examples that you can use in your daily basis. Most of you, I don't know, you are SREs or DevOps engineers, you can use in your dashboards to check, okay, we have this hotel call exporter sent logs records, to check if the logs, for example, in the case of logs, okay, if the logs are being exported to your backend like Grafana Locky or, I don't know, another APM or backend system that you have in your infrastructure. And also, like the refused log records, if you have any outage in your OpenTelemetry collector, this metric will be populated with the amount of refused logs. The queue size that Juracy just explained to us, how the queue will be configured in our structure. So if we have any outage or any problem in our OpenTelemetry collector, the queue size will get increased. And also the queue capacity should be related to the expected queue size in a case of outage. Oh, thank you. And there is much theory related to this OpenTelemetry collector, and for that reason, we brought here an outage simulation that will consist of telemetry gen. I don't know if anybody is familiar with this tool. Telemetry gen is a tool test that you can use to produce telemetry data for your OpenTelemetry collector. And we are going to trigger 1 million logs for the first local collector, which will do the first operations, the first validations of the logs. If the logs got refined, I would say that, then the logs will get exported to a second OpenTelemetry collector instance, which will exactly split the batches and do all the hard work before sending to our Grafana log. And to demonstrate that the metrics work, and then we're gonna simulate a crash that consists of removing completely the collector number 2, the collector backend, and we are going to see if we have a failure detected or not, and putting back, in the end, putting back the OpenTelemetry collector backend in operation. So, demo time, because it's too good to be true. Yeah, wish me luck. Just a second.
Oh no.
Oh no, yeah, no data. Yeah, thank you. So,
that's what you wanted to demonstrate, the outage.
Yeah, the outage. Yeah, no data. Take a look. Yeah, there is a really outage, right? Yeah, but to explain a bit regarding this dashboard, on the left side we have the queue size, and we have any if we have any logs received, and in the bottom of this dashboard the queue capacity and how much logs we got exported, and also the log key perspective if we have received any logs from the OpenTelemetry collector backend. Okay, and also during the outage simulation, we're going to see the send failed logs get increasing. Let me just create the first 2 OpenTelemetry collector instance. Oh, so anyway, we prepared this GitHub repo with all the description of this demo. We're gonna share in our social networks after this presentation with also the slide decks, okay? Let me just create the first one here. Just one second.
So
the hotel backend, and I just create the hotel backend, and let me create this not delete, apply, and we have create. Let me check if I get any pods on the default namespace. Yeah, thanks God, the pods are running. On the right side, I have opened. Yeah, thank you, Resi, for that. I have opened a port forward in our for our Grafana instance, and on the left side, I will open also a port for our local collector in order to enable the telemetry gen to read out the first collector instance. Okay. And at the second tab, I will start the telemetry gen. Is generating 1 million logs. Let's check our dashboard. Oh, we have some logs ingested. Yeah. Can you see that? I don't know why we are not getting this received. Let me check here if I okay, it's because of this rate. Yeah, save, let me go back. Okay, so then the queue size at that point is nil, because we have nothing queued to be exported because we don't have any outage. And the queue capacity we configured to 600,000, and we are receiving logs in the OpenTelemetry collector backends, and at the very right side, Loki is getting new logs every second. Okay, and thanks God, again, we cannot see any failed logs to be exported. Okay. Now I will simulate an outage on the OpenTelemetry collector backend to see if we get any telemetry data queued in our OpenTelemetry collector queue. Okay, just a second. Let me delete the backend. Let's see if it works.
That's the outage. So far has been only setting up the scenario.
Yeah, let me check if the part is gone. Let's see. Oh my God, it's not working. And I'm refreshing. Yeah, the queue is not getting increased. Ah. Yeah, it works. So, yeah, as you can see, we have some data queued. Okay, it's getting increased, and
can I make a comment here? Yeah. So we can see that the exported, so the number 61,420 on the second row, second column, matches exactly the number that we have on the Loki side. So it proves that we exported 61K logs, and Loki received 61K logs, but we keep receiving data. So our received is still increasing. So we are receiving data. We are just not able to export this data out. And the queue size is also increasing, showing that data is being piled up in memory or on disk until either we get a full queue. Our queue size here is 600,000, I think. And then eventually, anyway, so what happens now?
Yeah, what happens now is, someone from the infra or someone from the SR team act to put back the OpenTelemetry collector backend to the normal operation. And let's simulate that. Let's recreate our OpenTelemetry collector backend. Yeah, please. And now we got the OpenTelemetry collector backend to up and running, and let's see if the queue will get clear. It's still get increasing because we have some pending data to be exported, and now in a couple of seconds we should see this queue size decreasing. Hopefully.
Don't freak out. Don't freak out. That's fine. Don't freak out. That's fine. It's back, but there are so many connections piled up that we are just waiting for those connections to be retried. Right? So it's okay to have the queue increase. Oh, it's still increasing. Eventually, we're going to drain this queue because all of the connections are going to be retried. And because the backend, we see that the backend is working, right? So we have more data on the Loki side as well. So now we have the empty queue again, right? So don't freak out. It takes a while for things to settle back and to be normal again.
Oh yeah, thank you. And let me just stop our telemetry gen because our sorry. Yeah, because the demo actually worked as expected. Let me just to tell you, last but not least, we have, if you remember correctly, we defined a path to achieve the resilience in observability pipelines. And the last path is scaling and balancing. At that demo, we installed the OpenTelemetry, the Kubernetes OpenTelemetry operator, which help us managing the OpenTelemetry collector instances. And one recommendation from us today would be using this OpenTelemetry operator because it deploys a native HPA concept. So if you have to scaling your OpenTelemetry collectors so you can use this configuration. Regarding load balancing, you can use off-the-shelf solution in Kubernetes, like installing Nginx or Kong. I don't know what best fits in your infrastructure, and also using this strategy sidecar to deployment. In our case, in our demo, we used a deployment to deployment. One deployment will refine the data and send to a main deployment that will be the last mile in our telemetry infrastructure. But at that case, you can install a sidecar alongside your pod, and we'll do locally the first refinement, the first validation for your telemetry data, metrics, traces, and logs, and so sending to a bigger deployment. Yeah, we described here the deployment, but if you want to use, for example, daemon set is also capable in case of the OpenTelemetry operator.
Now, talking about the deployment architecture, resiliency is not only about configuring the collector to be resilient, it is also how you architect your deployment pipeline or your observability pipeline. So when using the operator, we have those deployment modes available. So we have a deployment where we can, they're just regular Kubernetes deployments, right? So they have random names or partly random, and you can scale up and down quite easily. We have sidecars, the sidecar pattern. So we deploy one collector per pod. So that's very good when you have like gRPC connections between those sidecars and another deployment internally, because we have a high frequency of changes of the sidecars. So we get very good client-side load balancing. We can make use of stateful sets as well, especially for scraping. They're useful. So for scraping receivers. And we have daemon sets, which are mostly useful for, not mostly useful, but they're more useful for single tenant architectures. So if we have multi-tenant, it's harder to get it done right. But I guess my point here is we have to consider the deployment architecture as well when thinking about resiliency.
Oh, sorry. As I mentioned in the previous slide when I recommended some strategies to use the OpenTelemetry operator, it's just a quick demonstration how the CRG defined by that operator could help us. Yeah, it's pretty usual. Yeah, you define the target CPU utilization. Yeah, it's the same in your deployment, for example. Then you will define how your OpenTelemetry collector will behave in case that achieve the CPU utilization percentage. It just was a quick demonstration of the operator CRG.
All right, so what's next when it comes to resiliency and the collector? So the first one, I think Yuri mentioned already, we have a few things moving around. So we have right now the memory limiter acting as a processor, and there are conversations at the collector project in moving that to be an extension instead. So a processor has already, so by the time that data got into a processor, it is already part of the pipeline. And if we have it as an extension before the receiver, we can block the pipeline without data getting within the pipeline. So the second thing that we want to change is, or that we are discussing, is making batch a feature of the exporter, so that we don't have a batching processor taking care of the whole pipeline. We now have batching on a per exporter basis. We know that we need better self-observability. So we need better metrics, and we have to test or think about other scenarios so that we can provide better self-observability of the collector. And we need component-specific resiliency as well. So we just got a conversation this week or last week on the collector or OpenTelemetry channel on Slack, where it was clear that we need better resiliency for routing and load balancer exporters, for instance, or routing process connector and load balancer exporter. Now, a few key takeaways, and I have only 1 minute. It's that, I guess the first point is not all of the pipelines have to be resilient. So perhaps it's fine not to be resilient in your case, and perhaps it's not fine. Resiliency is a concern for the whole pipeline and for the whole deployment architecture as well. Now, Collector has quite a few internal mechanisms allowing to survive backend crashes or problems in the connection between the collector and backends. We have metrics. Take a look at those metrics, get familiar with those metrics. They tell you the story of your pipeline. And in-flight data can also be replayed under certain conditions, so if data is on disk, and different scaling and load balancing techniques are available to achieve HA.
And the most important slide, thank you, if my French allows me, merci and obrigado.
Yeah, thank you very much for your talk. So unfortunately, we do not have too much time for questions, but I think one question would be maybe possible before giving the space for the next speaker. So if there's one short question, yeah.
Okay, thank you for the talk, by the way. I have the use case where I need to send data to two exporters. Is it possible in OpenTelemetry collector? If yes, how do you survive the outage of a single backend? What do you do for this? And if it's not possible, why so? And how do I need to live with this?
And a better thing to do is doing this strategy that we demonstrated in our demo. You send the data for the first collector, and in case you have an outage after this first OpenTelemetry collector, you're going to store locally in a queue, you know? Do you want to complement?
Yeah, I mean, if you have one data coming into your receiver and that is splitting into two exporters, and one of them is failing, what you can do is, right now, batching is batch processor, so it's before the exporters. So that's one use case that we want to fix for the future. But what you can do right now is you can send data to another pipeline via connectors, for instance. So you can use the forward connector, and on one, yeah, so that's one way of doing that today, right? So you have two pipelines, one for each exporter, and then you use forward connectors to send data. So each pipeline can be resilient on its own.
Okay, thank you. So if there are any more questions for those two guys, you feel free to reach out to them, either here, but I think we're not like going home right now, so you can just like find those guys and ask a few questions, because now we have to switch to the next topic. And thank you very much for your presentation. So, if you are curious how an IDE should be set up for ops, now we will have pretty much upcoming in 2 minutes the next talk. So now we are welcoming you, Sebastian, for the next talk. Feel free to start.
Hey, hi, my name is Sebastian Tietke. Welcome. If you want to have a seat, I stall a little bit. Yeah, I'm Sebastian. I'm the CTO and co-founder of Stateful. And we happen to make an open source project called RunMe, which is fairly new. I've been sort of like in software and cloud and operations for 20 plus years. And yeah, let's get started. Cool. So I have a confession to make. I talked to all of you math teachers. I thought it wasn't enough to go to a conference before a conference. So I had another conference with your math teachers before the conference. And they all said the same thing. They basically said that you guys were great about finding the solution, but you didn't always write down the steps how you got there. And while that's great, it doesn't demonstrate that you knew how to get there, but more applicably, it didn't document it for others, right? So it's a little joke, but it's also applicable because this is about documentation. And what I want to prove to you is that a IDE for operators, you could ditch the D, needs to be central to your documentation, or integral, I should say. We do the same thing in tech, right? We're very good about like producing solutions. We take pride in it. We love doing it, and we ship them, right? We push them out. We move on to the next project, right? Sometimes we're better about writing some docs and leaving a trail. Other times we are not, right? But at the end of the day, things haven't changed all that much. The one thing that's very different is math and physics don't change as much as technology does, right? And I don't need to quantify the order of magnitude, I don't know how fast math changes, but it's very slow. But tech is like, it's uncoordinated. There's, actors, companies, standard bodies that constantly just change things, right? So I guess what I'm trying to get at is that the how you get to a solution actually changes pretty frequently, right? So when you look at documentation, what tends to age actually pretty well, or when it changes, it's almost obvious, is the what, right? Maybe the why, right? But those two things are less susceptible to bit rot than the how, right? Because it's not like everything is like a car where you have an automatic transmission. You just know to put it in D and it will drive, right? Or you put an R and it will, it's like almost like a declarative interface to it, right? Instructions, the how is oftentimes, here's the steps you take, log into your AWS console, here are a bunch of screenshots, right? And good luck, those screenshots are probably gonna be different next week, right? So my point is like, it's also not as easy, right? So, but I'm here to like make a case that, docs should be integral to these integrated environments for operators, right? If you ditch the D here in the IDE. I know I'm kind of like almost made a case against it, right? Just talking to you guys here. But I do want to show you that it's actually possible, right? And Kubernetes to the rescue. No, kidding. Notebooks to the rescue. I do think Kubernetes is great. The one thing I will say is like, there's a bit of a halo around Kubernetes, and I think it kind of made us so that we're not innovating as much as I would like to on the side of things that interface with humans, right? Your terminal, your browser, your editor, right? I'm not saying IDEs don't progress, but I think, we've been like overly focused on sticking more stuff into an API that runs on the other side, right? And this, I'm not trying to say this is a zero-sum game, right? That's my whole point. It's like, I think we can do both, right? So Kubernetes is great, but this is about notebooks. So for, some of you, and it's interesting that I have a screenshot and you guys don't, but imagine it would be a Jupyter notebook here. It's really weird because it's definitely on my screen. Sorry? Magician, this guy figured it out. So there's a notebook here, and notebooks are essentially like a very good example of like how this sort of math way of demonstrating not just that you know how, but sharing with others and breaking it down into incremental steps. Some of which you actually at the time of running don't even have to comprehend, right? It's kind of like the superpower, but then when you want to, you need to, you can, right? And I think those are two good properties to have, right? So, like, I'm not trying to make a case for Jupyter notebooks, but I think it's demonstrated really well how powerful this could be, right? This is great for data scientists, great for any form of analytics. It's great for ML, but it's not necessarily built for the cloud, right? And cloud native and operations. So what we've done with RunMe is we said, like, look, if we could do what Jupyter did for ML and data science and just run our docs that interface with the cloud, wouldn't that be great, right? And by the way, I'm just putting this in here to be very clear. I know we have pipelines, right? But pipelines are not interactive, right? And I'm sure we've all tried to do that, and it kind of works, but it doesn't work great, right? Because it's not made for humans, it's made for machines, right? And I'm not trying to make the case against pipelines. I think these approaches can be complementary, right? Because you can run your notebook in a pipeline, turns out. So just a quick rundown of RunMe, and I'm going to demo a lot of stuff that is related to how we're using open technology. So I'm not going to try to spend a ton of time on this. But essentially, you can imagine, if you know Jupyter, that RunMe is a notebook implementation with a notebook kernel, but the kernel is not Python. It's Bash, but it's also like a cloud-native flavor of Bash. So it is fully Bash compatible, but it can do more, right? And what that means, I'm going to show in a moment. And as I said, it runs in CI. It brings all these concepts, like all these tools that you use, like a terminal, an editor, and all that into one place, right? Best of all, it kind of like gets you to a point where you can create kind of like micro control planes around a narrow description of a project, right? So your documentation doesn't have to go over to the walled garden of the AWS console and find the thing that you need to look for, right? It kind of brings it into the documentation. So let's actually hop over to the demo. Adam, if you could help me. So actually, let's start here. So like RunMe is essentially just, can you lift it up a little bit? It's essentially just Markdown. So you can imagine, like looking at this. This is a README file. It's just a Markdown document. The Wi-Fi here is terrible, which is why this is taking so long. But when it opens and it shows you the raw Markdown, you will see it's just Markdown. Maybe we'll skip that step. What we've done is, and it kind of ruins my surprise effect, is that I can just click that button and it just should pop me into a notebook. Let's wait 1 second. Come on. I already killed most of the parts that were somewhat online because of the Wi-Fi. Okay, well, I'll flip over and start it anyways. So if I hit the button, it usually pops it open, but it has to make an API call, like it hits a remote URL to resolve a local URI. But my point is, this is literally Markdown, and I can show it in here because it's not online, right? So on the right side, you see basically what you know, Markdown. I can even render it in a preview, right? Same thing, nothing is different, right? It reads Markdown and it renders Markdown. But what RunMe will do is like it actually makes it available as a notebook so I can run my steps, right? And it's a good way to escape Confluence and put your documentation back into your repo so it sits next to your infrastructure as code or your Ansible playbooks or even like your services for that matter, right? This is not something that is specifically meant for operators. You can use it for development, but I think this is a really good solution for people like ourselves that have the key to the castle, right? That platform other people that don't always can rely on a pipeline, right? Again, when I save this and I open it again, it's just Markdown, right? It just writes it back, serializes it back into Markdown. So we have Markdown here. This runs inside of VS Code. It's built on the VS Code platform. So you can think about it as it's like Chromium, not Chrome, right? So it can run in VS Code, but it can also run in Gitpod. It can run in code spaces. It can run as a web app locally, right? So there's a big portability aspect to it. It always comes with a terminal, an editor, a play button, and you can also record the output, right? So I'm not going to do the prerequisites because Wi-Fi is bad, but like you can describe either all the steps it takes to install something, or you can run the whole thing in a dev container and have all the stuff already installed because VS Code lets you do that, the VS Code platform. Or you can attach it to a Bastion host and have all the dependencies there so you don't have to concern yourself with like, is my base system ready to go, right? So let's skip to the first step. So to break up this walled garden that like cloud consoles can be, and like, let's cross our fingers, this is not gonna take half an hour to like reach the world and come back due to the Wi-Fi. But while we're doing it, let's start this one too. This usually takes split seconds if you actually have an internet connection. But But what essentially will happen, and it hopefully happens in a couple of seconds, is that you will actually get a list of your clusters with all the metadata like you would in the GCP console, right? It kind of is annoying that it doesn't do this right now, but this is entirely due to the internet. Anyways, I kind of move on and come back and see if it worked. When you share notebooks, you do want to share them in a way that other people can use them. So what RunMe does is it like piggybacked on this export nature, right? That you're exporting environment variables. But if they're unknown, you can, yeah, I guess we can't get out of the internet. But I'm happy to show you guys if you want to see it, right? And it's really cool, unfortunately. So this prompting based on exported variables kind of works in a way that like you can either make it a prompt, like I do here, enter your project ID, or you can make it a default value. So you can just confirm it, right? And a project ID happens to be RunMe CI. And then, this is a default value here, so I can change it, and I could scroll up to my cluster listing if it was there, if we had internet. But, I just confirm it, right? And hopefully this will not fail, but it probably will, so we'll just move on. This is entirely because the internet is not working, right? So this command here, the gcloud command, will just get you a kube context, right? And then I could go on and deploy an app in the cluster, and show you guys how to like tail the pods at the same time, all within the notebook here, right? But the sad part is the internet doesn't work, so I can't. But we're going to continue through it anyways. So all of this, both the terminal inside of it, as well as these cloud resources that you can inline, right? You can do it on the cluster level, you can do it on the VM level. It's like it's basically just a renderer on top of the API, right? Is our web components. So what I'm showing you here is like all of it is open source. Some of it is like steered by Microsoft, but it is entirely based on open standards, open source, right? Web components are W3C. Anyway, so there's a lot of open source in here, and let's continue. I mean, I'm gonna see if GitHub is maybe a better bet. So we can even like inline GitHub workflows, right? And that's cool for two reasons. You can either trigger one, or you can just check in on if your job's passed, right? But I'm not going to put a bet on it because it looks like the internet is getting in the way. Lastly, when it comes to open standards, we also support open telemetry. So I'm not going to do I wanted to pull in the SVG that renders the logo, but that's kind of like besides the point because it goes out to the internet. But what should have happened while I did this is it should have sent open telemetry traces to a Jaeger backend, and it did. I guess this is a previous run, but it does this anyway. So you can see how I have a RunMe session. It runs inside of a notebook, and in the cells and all the metadata. It's sort of like still in development, so there's going to be a lot more information available, including what prompts popped up. So you do get this sort of like paper trail, and it's all local, right? So you have control over it as a user. It's not like it's looking over your shoulder, right? If you run a cell and somebody says, well, we configured it to send it off to the security team, it's not like somebody is just tapping into your terminal, right? It's very explicit, right? And obviously it's like stuff that you can use, you don't have to, right? I'm not going to show to open the dev container because I'm also worried that it's going to try to pull something down from the internet. But you could literally, on my machine here, I could run this whole notebook inside of a container and have all of my prerequisites installed. And then that image I could give to anybody here, right? Or I could use our existing supply chain security and only use images that went through the vetting process, right? So it really kind of like just layers into all these existing technologies, right? Cool, hopping over here. Sorry about the internet, but that's not something I can control. So in a lot of ways, like my sort of thesis is like, if you run your documentation, it will not fall behind, right? If you make it like the front and center of like how you share knowledge, how you platform others, right? I mean, obviously, if you can platform people with a pipeline, please do, right? I'm not arguing against that. But I know that, like, if you have people on call, on pagerduty, runbooks, right? There's like a lot of handy-dandy stuff you can do just to gather information and, like benefit from retrospectives on outages, right? But I need you again, though. But there's a little bit of an elephant in the room where the hardest thing about making these notebooks generic, yet personal enough that you can just run them is the good old, configuration and secrets problem, right? And I know a lot of people are going to probably tell me we have Vault, we have Secret Manager, we have Cloud KMS, we have SOPs, yada, yada, yada. But my point is That's for machines. That's not for humans, right? I'm not saying that you can't store your secrets there, but it doesn't make it easier for humans to find them necessarily, right? And in a lot of ways, it seems like that there's sort of a dichotomy where you can either couple your scripts, your documentation to your personal environment, which I call the dot files, right, just as a label, or you can like couple it to your delivery infrastructure, right? You stick it into GitHub or GitLab or whatever you use. You can like manage your environments and all that. But at the end of the day, it's coupled to one or the other. You can't have both, right? So what that leaves you with, I don't know if you guys know this meme is like, being told like draw the 2 circles and draw the rest of the effing owl, right? Which basically means go ahead, reverse engineer it, whatever side of the aisle you're on, right? And, amp example, working amp, yay, right? But going from one to the other is not as easy as putting the car in drive, right? So I did the thing that I said I would never do, and I looked at this and I was like, hey, why doesn't the environment have a type system? And I went even further, and then I decided to build one. So the idea here is that like everything should live inside of the repo. Why can't we have a bill of materials that defines what your environment should look like? Kind of like a CRD that then can be reconciled, right? But something that can run locally as well as on an SSH Bastion host, but also inside of a pipeline, right? And I sort of like convinced myself that this is something that needs to exist. And I figured I have enough computer science jobs to figure out how to do string values, right? If I had nested objects, maybe I would have not tried it because I'm really not that good at computer science. So the idea really is to like have this triangle relationship, right? You have a set of environments, can be for humans, can be ephemeral, can be permanent. And obviously you have, even if you have just 2 keys, and one of them might be sensitive, the other one might just be a variable, right? You already have that problem, right? It's like kind of like, once you have another teammate, you have to share knowledge, right? It's like, unless you do it all yourself, you're basically exposed to the problem, right? And, I feel very strongly that documentation should be in your repo, code should be in your repo. Why can't we have a specification of the environment? So, yeah, I went ahead and did it. I had this in my head probably for 2 years, and then, since I had this talk, I had an excuse to actually build it, sort of. And, I called it Project Owl because, remember, the owl. Also, the owl is a very wise animal, turns out. So the idea here really was, build a way how we can specify, validate, and resolve, right? But the resolution here is flexible, right? So we get to that. Environments, so that we can make them verifiably correct, right? And like, the things that I kind of looked at is like, I liked what the SSH agent did for keys, and like how you have APIs that make it easy to stick stuff inside of it, but you can't actually really read it out, but you know it's there, and you can kind of check that it's correct. And I like the relationship that TypeScript has with JavaScript, even though you could argue, why is TypeScript not just JavaScript, right? But, like, the type system shouldn't be, you have to adopt it all, right? It should be progressive, right? You can have as much as you need, because the environment usually is like, you have 100 environment variables, but 5 or 6 of them are actually really the difficult ones, right? And then, like, so to kind of get closer to this idea of that you can just single sign on to every environment, right? And like, whether it's, like a personal one, whether it's a machine environment, whether it's a ephemeral one, you should just be able to use your identity or any other contextual information, what machine you're running on, and that's sort of the resolution aspect. So looking at this, real quickly, I kind of like need to make sure that I'm not running out of time. I looked at what are we already using, right? And it turns out that like this examples file, that .env.example is pretty dominant, or like .sample, fill in your blank, right? So what I did, and this is really just a interface to it, it's like sort of a front end or facade, if you will. I kind of came up with like an annotation, way of just adding a comment, a type, which I call spec because everything is a type, kind, type, everywhere. So I call it a spec, an environment spec fits really well. So you have a concrete type, and there can be many of them. This is like the subset of it, which I built in the last month. And it's basically more about security and making it so that you can shield yourself from like not taking screenshots of your environment without having masking and all that. And then an exclamation mark just means like mandatory, right? It's like it has to be there, right? So when you start out, you pull in a repo, it will like look at your environment and tell you what's not there, right? Which is in my mind already a pretty big help, right? And then like if you made more concrete types, you could even go. Regex is obviously very specific. But you could have a DB URL checker. You could have a host or like a socket checker, right? So you could like formally validate that the value also is correct in the way it looks, right? Maybe you can even make a ping to a database and see if you can connect, right? So there's a lot of tooling you can also build on top of it, which I think is pretty exciting because like what TypeScript has done for JavaScript developers is not just make it type safe, it's also build a lot of cool tooling, right? So you can have autocomplete and all that sort of stuff. And I think that's what we're missing in userland, right? So, you know, the relationship is this, I'm just gonna blast through this real quick. Name, value, we already know that. The values oftentimes are just dummy values, but now we have this spec idea, right? And it kind of like creates this relationship that you have to have these three things to be able to like establish correctness, right? Sort of at a compiler level almost, if you will. And then what I've done is like I wanted for users not to having to be exposed to any of the internals. That's why this .env.example interface is really easy to adopt. And you can just use as much of it as you want, but inside of it is a graph, and it's using the GraphQL type system to traverse that graph. You don't have to write any queries. It's not a data API. It just uses a graph to model your environment, the types, and the resolution. And at the end of it, it just traverses it and spits out a .env, right? A serialized key value pair, right? Like a list of them. But the cool thing is that as you traverse the graph, you can use contextual information like authentication or OIDC credentials. I mean, like all of stuff that I haven't built yet, but it's infinitely like, powerful, right? And the hardest part is like, how do you build an interface on top of it that is not the graph, right? So you can use it like the .env.example. But like I kind of want to do that, but I need more input, right? And the idea really is not to reinvent the world, is like just connect the dots, right? If your secrets live in Secret Manager or in Vault or AWS, maybe you can just use a convention to resolve them, right? If you have the right, permissions, the right role that you can assume, you should be able to do that. Why not let the graph handle that for you? Make the OWL do it. And I'm calling this the OWL store because it's inside of the kernel right now, but it's not an integral part to run me. It can also run on its own. And what it will let you do is like the SSH agent. It essentially will let you it will let you interact with it. It has APIs, and it will be able to like resolve environments if I were to build that, right? So like the idea really is to use OWL as a thing that can be by itself and stand alone and solve this problem in sort of a Unixy way, right? Like as a tool that is universal, right? And also OWL is a much cooler three-letter acronym than env, I thought. So OWL store, env store, kind of works, right? So enough of the theory. I'm just going to blast through this. Adam, can you hold the microphone, please? So I've kind of been using this while you guys weren't watching. We build a UI on top of it. It's all gRPC interfaces, so it's we also have a CLI for it. But if I reset my session here, you can kind of see how those things are unset, right? And the reason why that is because I defined it here, right? My environment obviously has all these systems. It can come from my profile, whatever I stuck in there. So the env store assumes that like if it's not known, it's semi-sensitive. So don't show it to anybody. But if I wanted to, because we don't know what it is, I can, right? So it's not marked as a secret. I call that opaque, right? So if I now took a screenshot, I can be reasonably safe that I'm not leaking anything, right? It's pretty simple that way. And then, can you bring it a little closer? And then it will also be smart enough that like if it already has a value, if for example, I go in my .env file and enable this and reset my session, it will show me where that value came from, right? So this came out of .env because like, I'm sure you guys have done this before where for the life of it, your process has an environment variable, you could not figure out where it came from. Or it took much longer than it should have, right? The one thing that I should probably mention, we'll get to that in a moment, try not to run out of time, is that I'm not just saving a value, I'm saving like basically transactional changes to the environment. So at any point in time, it will be snapshotted, so it will almost run the total of it and show you what the environment looks like at that point in time. But conceivably, you could traverse the graph at a later time. So you can also like figure out how it evolved over time if you wanted to, right? If you wanted to like really see, oh, I ran a cell and I, test cluster, right? Or 1, 2, 3, 4, 5, and boom, the values are in here, right? My secret is masked. It's not really a secret, but I did that for demonstration purposes, right? And even the prompt that I can rerun, well, if I actually rerun it, it already has value, so we'll just skip it. But I can force it to like prompt me again, right? And again, this resolution mechanism of using a prompt in the notebook UI is just one way of resolving it. And in my mind, it's the last resort, right? It's like, if I can't figure out what the configuration is, if it's the master password for the DB that's in my 1Password, maybe I actually want it to ask me, right? Like, do everything else, and then ask me for the one critical thing, and I'll go look it up. But don't ask me for, the endpoint, the host, the DB URL, yada, 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 right? So like the idea really is to like make it as easy as possible, but also pragmatic, right? And the same thing is available in the CLI. Maybe I'll skip over that because I hope you guys just trust me that it's there. Actually, I can run it real quick. Run me in snapshot. And I can do all, and it shows you the whole thing. But the whole point is like, this is not Miri to run me. Yep. Cool, so going back here, this was the demo of it. It works end to end, it's experimental. I'm not a very good Go developer, but I'm pretty proud of myself. It looks a little ugly under the hood, but it works well. So I already talked about this, so I'm gonna breeze through that. On the outside, it's env example. On the inside, it's a graph. You don't have to know anything about it if you're not working, if you not want to extend it on the internals, right? It's totally possible to put another facade or front end on top of it, which could be a CRD, and then a Kubernetes controller that does the reconciliation, right? But the whole point was like to not mirror it to one specific, thing, right? And like especially not to a server exclusively, right? Something that's doesn't live on can't run locally at the user, right? At the human, right? And it happens so that runme uses the last resort default resolution as prompting, but that shouldn't be the end of it, right? So I do want people to tell me what they think and what they want, so I can maybe prioritize things a little bit, because I could build anything, and that's really, really not a good thing usually. Just real quick, this is how it looks on the inside. So I told you that like it kind of like adds to the thing as you run through the notebook, but you could conceivably do this with terminal sessions. There's like a lot of things you can do, and then it has the whole defining those specs, overlaying them, and then validating them, right? Like right now I don't do correctness, I only do mandatory or not, right? Because there's only so much one can do in a month. And then again, the GraphQL engine that's on the inside that does that is completely air-gapped, no network interface, it's all in memory, right? It has nothing, it is not a GraphQL server. I want to be very clear about this. And then, this is kind of how it looks like on the inside. You can even build a different front end, how to get these specs into the graph, or then how you do a resolution path, right? And I kind of like, this is made up, but I kind of have a little bit of a POC implementation where you can then add to the graph, and this can also be a different facade, right? Nobody has to write this query. I could stick this into a CRD and then generate that query, because it's just an AppSec syntax tree, and I just rendered it so we can look at it, right? And like you can basically have a chain of things and then try to resolve values, and then if you can't resolve the last one, you can prompt the user, right? Or maybe you can resolve them all, and it really also depends on how much effort you want to put in, right? But it gives you the whole toolbox, yeah. So just to be clear, absolutely no GraphQL in userland. It's just I'm showing you guys how the sausage is made. And then this is an example of different facades, right? It could be a CRD, right, that just defines the spec. There could be a CRD that tells you how to take the specs and then run it through the graph and grab the values from sealed secrets or from AWS Secrets Manager, right? I haven't built that yet, but it can be done. I also have this plan of like, using runme in a way, kind of like how cloud functions work, but they run locally, right? That you basically just name the cell after the key. And then if you are locally, maybe there's a resolution mechanism that actually just generates a key, because like you're running in development, and who cares, right? And just make this like that simple, right? And or like you use a CLI tool that already runs through an OIDC flow and just spits out the token, and it just gets sucked up into the graph again, right? And the idea here really is to build a common set of specs that do all of this stuff so we can share them, right? So you don't always have to reinvent the wheel. We can define our environments with common specs. We can resolve them, right? It's sort of like a tool that benefits the community, right? And I'm really interested to hear what you guys think. And that's kind of it. I'll be at the KubeCon C30. Happy to talk right after. Happy to show you guys all this stuff that didn't work because of the internet, which is really cool, I promise. And yeah, that's it. Email me if you have questions, if you like this, if you hate it. I also want to hear if you hate it. Really, I do. I'm not going to take it personal. But yeah, thank you. Merci.
So, thank you very much, Sebastian. I think we have 1 minute left. Does someone of you have a question to the speaker?
I did build a type system for the environment, so somebody has to have an opinion about this, please.
Any questions? No?
just sinking in still.
So then you just left no questions?
I know. So it's basically perfect is what that is.
Either this or just no one was understanding what you're talking about.
Well, if you have questions or you know something didn't compute, just come to me. Like I'm happy to talk about it. I really want to talk about it. There's a lot in my head. Thank you.
Okay.
Merci.
So now we have a lunch break. Keep also in mind from the schedule that it's 2 p.m. It's only on the main arena where the next talk starts. This one is about 3 o'clock. So this area is going to be empty until then. Thanks for your attention.
Hello. Is it working? Yeah, hi. All right. Hello, everyone. Welcome to our afternoon session in the VIP room. Our next speaker is Łukasz, and he's going to talk about no GitOps, no pain, right? Yep. Give it a go.
Thank you. And first of all, thank you all for coming. My name is Łukasz Piątkowski, and I work with Giant Swarm. I have nearly 8 years of working experience with Kubernetes, but most recently I'm working with a team that is responsible for developer experience, and part of this developer experience thing is our GitOps setup. And today I'm gonna show you something that comes from our experience from running that for a few years. So, as you might get from my very long title of the presentation, I'm gonna touch mainly 3 areas, or actually intersection of them. This is the platform, GitOps, and Fleet. So let me briefly introduce these 3 areas, because in the intersection where we are, there is something, and this can be pain, and I hope that I can help with this pain at least a little bit. So our 3 areas, GitOps. I think that's the easiest one to understand, and everyone knows what it's like. You put everything you have as a code, your configuration, your infrastructure, your applications, everything. You describe this as a code, and then you keep this code in Git. Bam, you have GitOps. Platform is a little bit more vague. Vague in this sense that it's not something you can point a finger to and say that's it. But the general idea over here, the general idea over here is that we build a set of tools that makes your developers and DevOps move faster, and that makes deploying and configuring applications, especially at scale, easier. So the third hero is fleet management. And let me briefly introduce the setup that we use at Giant Swarm for fleet management. Over here you can see 3 main interested actors or parties, if you will. This is, on the left side, this is our team. So basically a team on a provider side that is responsible for delivering everything that is needed for a customer to manage Kubernetes, or actually a fleet, so a set of Kubernetes clusters and stuff that goes on those clusters, so deployments, applications, and everything. The other party is the platform team, already on the customer side. This is usually a group of people that really needs to be the glue between what is needed, what is internal, what is expected from a platform on the customer side, because every customer is different, and what developers from this specific customer need. And then we have dev teams. So the purpose of dev teams is basically to not be blocked, to move smoothly, to move fast, and be able to deploy stuff quickly. And to make it work, we isolate our customers strictly into environments that we call installations. And every installation consists of a single management cluster, so basically a cluster that is responsible for doing stuff to all the other clusters. So creating, upgrading, managing, deploying applications, everything. Your control point for what we call an installation. And then we want to drive all of that with a Git repository. And here you have it, a platform that is driven by Git, and you have a fleet, and everything is done. Thank you. Well, no, not really. The problem is that this is very oversimplified, especially on the left side. This Git repository component turns out to be pretty critical. I mean, there are problems. Obviously, Git is cool, right? Allows you to do all the stuff with code, text merging, and everything. But, well, Git has some drawbacks. And I don't even mean that. I mean, this can happen, right? And you have to keep it in mind, because it will, most probably. But, okay, that's not what I meant. What I meant is that if you want to drive everything with a GitOps setup, the structure of your Git repository is really critical. So you have to really focus about how to lay out your repository, how to structure your repositories to make everything work. And then still, even if you do it really, really well, everything evolves. With time, you will have to do some migrations. That way or another, there will be migrations. And that's going to be your second big pain point. And then there are some honorable mentions that maybe we will get to at the end, okay? Let me start with the most important thing, so repository layout. How do we deal with it? Like I said, I'm working with a team that is doing this for quite some time now, so how we approach it? No, not really. I mean, that's the original approach we wanted to take, but then someone said that we are professionals and we shouldn't, and you know, stuff like that, and expectations, right? So, okay, we decided to do it another way and started to figure out what are the general ideas about layout of a GitOps repository. And it turns out that there are three main ones. Using by directory, by branch, and by repository layouts. By directory, pretty simple. Single repository, single branch, you separate your environments, whatever environment means to you. This can be your dev, prod, and staging environment, or this can be US, East, West, Europe, Asia, whatever. Environments, right? Stuff that you need to have a slightly different configuration for. You put them into different directories. This is pretty simple. It's easy to do a consistent change that affects all the environments at the same time. What is bad is that it's really hard to set permissions because there are no per directory permissions, at least by default in Git. And it's also bad for separating tenants, because if you have multiple tenants and you need to strictly separate them, you can't really do that with this setup. By branch is quite similar. I mean, in here, we are creating a branch per environment. So for example, what you have in a dev branch goes to the dev environment. A very clean and easy way to see what is really deployed, for example, to a dev environment, because it's good enough to check out the dev branch and you're done. You have full visibility. But it shares similarities with the by directory layout because still permissions are a problem. And here there is a new problem that is doing a consistent change. If you need to apply the same change to all the environments, it suddenly turns out that you have to track the same patch across different branches, cherry pick it, and so on. It's easy to get lost. Totally doable on a technical level, but needs a lot of effort. So the final approach is by repository. It's good for permissions, because you can set different permissions for different repositories. It's good for isolation for the same reasons. It's bad for doing consistent changes, because if you need a change that goes to multiple environments, this means you have to go to every one of them, most probably. We will see a solution later, and do the change, right? So you basically repeat yourself over and over. So what's the choice that our team has taken and that we apply in production? The answer is everything. Why should we choose? We don't choose, we take it all. Right? So here's our opinionated approach. We will use different ways of structuring a repository to achieve different features of our layout. So we will use multiple repositories to keep customers' isolation, because that's what we definitely need and want. We will also use a top-level template repository to not repeat ourselves, and we will reference this repository from different places. We will also keep multiple branches. By default, our normal deployment branch is still main, but for example, our customers, they sometimes go into what they call a feature freeze. And with the feature freeze, well, we are not allowed to change anything on their infrastructure, literally anything. So we can create a branch that is frozen for some time and reconfigure their infrastructure to be configured using that branch, and later we will configure it back and merge it back. And finally, we will use multiple directories to manage different environments, different clusters, and so on. Here's that idea in a more graphical form. The top level, the pale yellow repository, is our templates repository. So in there, we provide different templates. I guess the font is a bit small, sorry for that. But I hope it's still at least a bit readable. Over there, we keep templates. So for example, you can see their AWS template or Azure copy template. Copy is cluster API, right? A native way, declarative way of creating clusters using another cluster. So you're basically just doing kubectl apply an object, and this object means create me a new cluster, for example, on Azure or on AWS. But it's not only clusters. This can be anything you want. For example, applications that are common and everyone uses, like Grafana, or maybe something else, Prometheus, whatever. We put those templates in there. This repository is not standalone. I mean, it can't be applied directly to a cluster, to an environment to configure it. This is only a base set. And then we have this yellow and orange giant swarm repository. That's the repository we use to configure our management clusters. So we use our own base repository, the templates repository, to get some templates from there. And using these templates, we instantiate and configure our management clusters. If a customer requests a freeze, we create a branch in this repository and reconfigure the selected management cluster of a tenant of a customer to point to this branch. And then we have actual tenants, like the blue and purple one. They also use the same base set of templates that we provide in the top repository, but they are owning these repositories. So they can change whatever they like. They can include whatever they like. And then this is applied to their infrastructure. So what are the benefits? Well, git blame is one, right? No, not really. I mean, git blame can be useful. You can learn who made the change and you know who to contact, who to ask, with whom to explain. But the most important benefit for us is we have dry configuration. So we provide a template in a single place and it can be reused in all the other places. That's good. We have strict customers isolation. We actually have a different configuration repository for each of the customers, so there's no crosstalk between the repositories. We can't hopefully get anything cross-polluted between different separated customers. And we expose our customers extension points, so they can include what they want. We don't know everything. We need to allow our customers to customize what they get. For the platform teams on our customers' side, this is also really beneficial because when they start to build a platform, they need to use their internal knowledge. We, as a service provider in this case, we don't know everything. We can't estimate, we can't create any possible template. We can't provide every possible configuration. What is needed is the knowledge, internal knowledge of specific customer about their processes, about their deployments, about how they do stuff in very general term. So instead of forcing them to use our ways, we provide our ways as an opt-in set of templates, and they can choose from those templates whatever they want, apply, enhance, extend. They don't have to start from scratch, but they can modify, they can include their knowledge and their skills and their procedures, and then expose that to developers. So that developers in their company, they have a lot of options to choose from, but these options are already tailored to their needs. And hopefully this will make their lives easier and this will allow them to move faster. I won't be talking much about tools here because what I'm talking about is really pretty generic and doesn't really depend on the tool. But as you know, well, there are in the Kubernetes space, there are two most common projects, Argo and Flux. We chose Flux, we really like Flux. Solves some of our issues right away. I really recommend the project. It has a full native API for managing GitOps, but I'm mentioning this only because I wanted to show you quickly a simplified example. So this is how a cluster configuration can look like. The important part here is that we have these two code blocks. One is called resources and the other one is called patches. So resources tell us what this cluster is built from, which objects need to be pulled in to create this cluster. This is a management cluster, and as you can see in the first resources line, we reference a remote repository. That's the template repository, and from there we pull a template for a CAP-A cluster. CAP-A is copy for AWS. That is also configured to use Flux v2. That's our tool, that's why I also mentioned the tool. Additionally, in the second line, we include an extra feature of being able to manage EKS clusters. This needs some extra controllers to be deployed, and that's included in this cluster as well. And then we include a config map, we include some secrets, and so on. But these are only templates. unfortunately, this is not a templating language. This is a full configuration that can only be patched. So basically, you're overwriting part of this configuration to get what you want. Hence, we need patches. And that's the more verbose part of the configuration. I shortened it here considerably. And I'm just showing you 3 examples of a patch being applied. This patch can come from an upstream repository as well. So if, for example, you have to, or you want to disable a certain feature, you can use a patch that is being available in the template repository as well. This can be a shared template, shared patch template from your own repository as well, like the second example, or this can be something really simple and inline patch, like in the 3rd line. And here you have it, a configuration that is taken from a base repository with custom patches that make it work in this specific sense. So that's the brief description of how we deal with the problem of repository layout. Let me now move to the second problem of migrations, because like I said at the beginning, well, at some point you will get to the step of migrations. You can start good, but it's really impossible that you won't have to make any changes. And actually, migrations turned out to be pretty good for us. I mean, there's a general approach with a tool like Flux. You can suspend the reconciliation. So you can tell your GitOps controller that, hey, for some time, starting now, don't apply the changes that go into the repository to my infrastructure. Pause it, okay? And then you suspend all the objects, or you just suspend all the controllers to be sure that nothing is really touched on your clusters. Then you do the changes in the repositories. You check them. Because the setup is pretty complex, you double check them. And then you ask someone for a review. And then slowly, starting with a test cluster, you start to resume everything in exact opposite order that you paused that. And if you did everything right, you can move stuff around. You can move stuff across repositories. You can move stuff across directories. You can change patches. You can do everything. And this is pretty good. And to help you with that, we have one extra feature that is called pruning. Pruning is pretty nice. What it means is that if you label an object with a flag that says prune true, it means that if a file that created this object is gone from a GitHub repository, it has to be deleted on the cluster as well. So you have something, you have a file, this file creates, let's say, a deployment. You delete this file, deployment is gone from the cluster. You don't have to clean up anything manually. Life is easier. Example, over here. Commit number 1, we have this 3rd line. This includes a certain controller. Commit number 2, there's no line at the end, and it's gone from the cluster. You effectively uninstalled an operator or a controller, right? Wait. Oh, yeah. Someone dropped an A in refactoring. There's not much difference, right? Both extensions are valid, except that this file doesn't exist in the remote repository. And this means that all the objects that were described within this file, they don't exist now in the rendered template. This means that with prune set true, we've been there. And it works exactly the way you expect. That's our test cluster named Grizzly. I asked DALL-E to picture the situation that we were in. I think the picture is really accurate. That's exactly how Grizzly looked like at that moment. So we actually recommend, by our experience, to not use prune true by default, because this is a double-edged sword, and you can cut yourself with it. So our recommendation, no, set prune to false everywhere for migrations, and only deliberately turn it on when you're sure that you want pruning and you will be cleaning something up. Otherwise, it's easy to shoot yourself in your foot. Okay, so migrations, not that much of a pain, but a risky process. Pay attention to what you're doing. And now, like I said, some honorable mentions. I won't be going now into the details because, well, GitOps should simplify things and make everyone's life better and happier, and I'm talking about problems and more problems and dead grizzlies. Doesn't seem to match really, right? But yeah, well, by introducing a solution, you're also introducing some new problems to handle. So first problem, and we don't have a great solution for it yet, is about understanding the impact of your change. Like with this refactoring with prune turned on, no one was expecting this result, right? But it's also entirely possible that with the setup where you have remote repositories, everything connected in different directories and so on, you do a change on the top level repository and you will be scratching your head wondering what will be the actual impact on end clusters, on the end rendered configuration. We have some in-house tools to do that, that pool resources from different sources, merge them together and render and so on. Unfortunately, that's very custom and not usable to the wider ecosystem. And that's where I think we still need to work on improving general stuff, because I think this should be possible. This is very important that before you commit a change, you really understand the impact of this change, and you can preview this impact and not only think what you think that this impact does, this change does. Complexity can also build up quickly. I recommended a GitOps setup, a Git repository layout, but then you have patches. And on top of patches, you can have more patches. And on those patches, you can have more patches. And suddenly, after the third layer of patch, no one can understand what the final result is without really rendering everything out and checking the output. Be careful, don't overdo it. And also don't overdo it performance-wise, because Flux that we use in our production setup is really great in terms of performance. But we've seen some customers that were expecting this to be a rapid recovery tool. This means that if someone deletes anything on the cluster, it will be recreated within 10 seconds. So set reconcile to 10 seconds. No, you can't set reconcile to 10 seconds if you had hundreds of big objects that have to be reconciled. You will kill your system. Okay, so summary. We are building platforms. Our main objective is to make developers and DevOps lives easier, and that's the important part. And GitOps is great, and it indeed solves problems. It makes your life easier. You have a single source of truth. You have the ability to customize, and it can be made elastic. It's all good. Just remember that it's not perfect. You introduce some solutions, you also introduce some problems. Think about those problems in advance. The sooner you do that, the less problems you will have later on the way. And also my recommendation is, whatever tool you choose, make sure that you really know this tool well. Because, for example, in our case, from Flux, we use almost everything Flux has. It's important to know what you can get from the tool before you start, building your own tools, your own shovel, right? And quick links if you're interested in more. The first one goes just straight to the Flux repository. The second one, we actually created as a company a public repository for our customers that want to opt into GitOps management, where they can go and learn and see and get a ready template structure that they can start with. It's a public repository. Go there if you want to learn more and see some examples. Also, I'm not sure if you noted that this top-level repository on my graph had an arrow and it said this can be public. So yeah, actually at Giant Swarm, our top-level templates repository is public. The repository that we use in production and apply everywhere. And that's the third link. You can go there and see how our config is structured and what we apply and how does it work. And finally, the last link is something that I'm preparing, still. And last commits this morning. But using the Oracle Cloud Infrastructure free tier, you can get a very reasonable, completely free, as in no money involved, Kubernetes cluster. And I have a setup that creates this cluster for you and also bootstraps full Flux management there and also deploys some extra tools. So if you want to practice, if you want to learn more, if you want to see how Flux works, you can go there, contribute. Really, contributions very, very welcome. But you will get a real cluster entirely for free. And you can play with it and destroy it, well, better before you apply, something really serious there. And with that, I wanted to say thank you. And if you want to download the slides, here's a URL for it in the QR code. Thank you very much. And if there are any questions, I'm happy to answer them.
Questions?
Thanks for the talks. And yes, Flux is a great tool, and Flux is scary. And there is Flux diff customization to give you really a server-side rendered output of what it wants to do. Just want to mention that.
Yeah, we know we use it. It's part of the tool that I mentioned that aggregates all the repositories and renders the output for us.
You mentioned that part of why you decided to go with Flux was that it solved a few of your problems immediately. Could you explain which problems it solved in comparison to, for example, Argo?
Yes and no. I mean, I won't directly compare with Argo because I haven't checked, at least for some time, Argo development. So my Argo knowledge is not up to date, and it's entirely possible that Argo can do exactly the same. That's why also, like in the most part of this presentation, I'm not really referencing to Flux. It's just a tool that we use. Argo is, in my opinion, like probably 90% on par, and you can achieve exactly the same thing with Argo. What we are happy, especially with Flux, about is full native API, which makes it possible to use Flux as a building block, not end product, end result. But by using this native API, you can immediately make it part of something bigger, like a platform. Then we really like the composability, so the ability to merge with remote repositories that I showed as a key factor over here as well. And also pretty easy secrets management, secrets encryption within the repository. Oh yeah, that's what I mean also by native API, right? Everything you create with Flux is a native object, and normal RBAC rules apply like to any other Kubernetes object.
Anyone else? More questions? No? Thank you very much once again.
Thank you once again.
Should be working. They're working. Okay. Hello, everyone. We have Ida and Kat from Grafana. And yeah, go ahead.
Okay, thank you. Hi, everyone. Welcome to our talk. Thank you. Welcome to our talk, You're Good Enough, Combating Imposter Syndrome in Cloud-Native Communities. And so we wanted to start off with some intros. Besides being two software engineers at Grafana Labs, who are we?
So my name is Ida, pronounced she, her. I'm originally from Eastern Europe, but currently I live in Berlin. I identify as a woman, as a feminine person, and I'm actually a mathematician who works as a software engineer. In my free time, I'm actually a trained classical singer. That's my hobby. I'm a big fan of drag, and I bake sourdough bread, and currently, or recently, I became also a community organizer.
And I'm Kat. My pronouns are they, them. I live in Brooklyn, New York, and I'm a second-generation non-binary Asian American, and I'm also a sociologist turned software engineer. In my free time, I'm a mahjong player, photographer, learning how to dance, and I'm also a foodie. So to the right, you can see me with some snow fungus stew I made, which is a traditional Chinese medicine, and if you're interested in the recipe, you can come talk to me after the talk. So we have a few goals for today. The first one is for those of you who have maybe never experienced imposter syndrome, or you don't experience it at the moment, we want to help you understand how to support your colleagues who do experience imposter syndrome. And our second goal is for those of you who do experience imposter syndrome, we want to help expand your toolkit to manage the symptoms and give you tools to empower you. And by doing the first two goals, our ultimate one is to strengthen the engineering community. And so our pitch to you is that less imposter syndrome leads to happier engineers, because trust me, and I know, if you're not suffering, you're more likely to enjoy being at work, and this will lead to more productive and connective teams, because if you're on one, you're more likely to stay at the company longer, work better with your teammates, resulting in lower turnover rate and saving the company money.
We also want to manage your expectations. So even though Kat is a trained sociologist, we are both software engineers, and so we are not psychologists. We just were thinking that even though we are not experts on the topic, we managed to create something that worked for us, and we would hope that it would work for you as well.
So let's start with defining imposter syndrome. It's a term coined by psychologists Pauline Clance and Suzanne Imes in 1978, and it's estimated about 70% of people have experienced it at least once in their lifetime. And so let's talk about some symptoms. Perfectionism is one of them, and it's one that I struggle heavily with the most. It's setting impossibly high goals for yourself. For example, when I first joined Grafana Labs, fresh out of boot camp, I thought, oh, within a few months, my engineering manager will realize that I'm actually at a principal level and re-level me. But really, that wasn't the case. Superheroism is closely tied with perfectionism, and it's over-preparing for tasks, so you seem more than capable of doing them. For example, when Ida and I were preparing for this talk, I wanted to take an hour each morning just to myself so I could perfect my script, perfect the slides, so I could show her a polished, finished product before we even started.
It was polished.
Thank you. And these two things can lead to a fear of failure, because now you've set the bar extraordinarily high. Also, attributing one's own competence to external factors such as luck or someone else helping you is another symptom. And this one is also tough for me, because coming from an Asian household, we were taught to be humble, so sometimes owning up to my accomplishments feels like bragging. And lastly, all of this can lead to anxiety, depression, and burnout, and you don't have to check all the boxes, but I encourage you to think if any of them affect you. Lastly, discrimination, social stigmas, and microaggressions could exacerbate symptoms of imposter syndrome for marginalized people.
Especially when you're, for instance, a first woman on the team, and people left you out of technical conversations, or they don't ask you any technical questions, it makes you feel more of an imposter and less connected to the team. So what do we do? How do we fight imposter syndrome? We will offer some steps and some tips, but before diving into steps and tips, I want you to consider the perspective that really shaped our talk or our approach. So when we talk about software, all of us, we work on some code bases, or most of us, I assume. We have a scale of stronger and weakened systems. I think usually we are somewhere on that scale. What makes a system strong? It's reliability, testability, maintainability, and so on and so forth. This is not something we are going to talk about. But if this system breaks with introducing a small bug, or it's broken, how do we as engineers approach this issue? Usually the solution is, I don't know, it depends on your bug, but adding more integration tests or introducing more scaling. So we look at the system as a whole, and we are trying to make it stronger and more resilient, also for future bugs not to be introduced that easily. This is a perspective that I really want you to keep when we are tackling imposter syndrome. So our mantra for our talk will be, fix the system, not the people. Here, the system we are talking about, not a software system, but about feelings and emotions and being on the team. So who is actually the system? The system are mentors, C executives, leadership, managers. Every single person in the organization is the system. Everyone creates the culture. Of course, leadership and management and people who create values, those people have a bigger impact on the culture, but every single person does have an impact. I mentioned on the previous slide mentors. So what is mentorship? Mentorship is a relationship between two people, between a mentor and a mentee. Who is a mentor? Mentor is a more experienced and trusted person who can give advice and help out. And so for instance, Kat and I, we are in the mentor-mentorship relationship. And I personally did not consider myself being a mentor until I started doing it. And I would encourage definitely everyone here to think about if they could be potentially mentors. I would ask these questions. Do you like people? Are you passionate about helping others? Do you like connection? Do you like connecting to others? Or would you like to be better at connecting to others? If any of the answers is yes to any of these questions, please consider mentorship. Even though if you tried mentorship and it didn't work out for you, mentorship is like any other relationship. Sometimes it's not the match. And if you're not the match, try again with someone else. I was really lucky to have Kat, and we managed to vibe really well. So let's dive into specific steps how to tackle imposter syndrome. So we will be talking from a perspective of a mentor and a mentee, because that's our relationship, but this can apply to anyone who is to any leader or a team member, individual contributor. So my motivation for my mentorship style was definitely, I was trying to give what I wish I had. So me as a feminine person, I usually was the first woman on the team, and I wasn't connecting easily to my colleagues. It took usually a lot of time. I'm not into gaming. I don't care about the release of the new Apple Watch. So it was, it was really difficult. I felt really alone and isolated most of the time. And don't worry about me now. I have a great mentor, hi Serge, and I'm taken care of. But this heavily influenced how I approach mentorship. So be present and listen. So active listening is you're being present and you listen to what the other person says, but also you look at their face and maybe listen to the tone of their voice.
And so, for example, Ida will always point out when the tone of my voice goes an octave lower, because usually that means I'm stressed or worried about something. And whenever she does that, I go, oh, she's really paying attention to what I'm saying.
Yeah, and for instance, eye contact, also very underrated. If you're in a meeting and you're scrolling through your Slack slides or you're pushing a new committee or PR, I would encourage you not to do this in your one-on-ones, because these things, especially many of you, I assume, work on remote settings, and keeping a connection online or building a connection online is not simple. So these things can make a difference. Also, some facial expressions, they even change the tone of your voice. I'm not encouraging anyone to smile. I'm a woman. I don't like to be told to smile. So, but these things do make a difference.
And so another tip that we have is being curious about your colleagues. And I would say that Ida's interest in me set a foundation for me to trust her. So for example, when Ida and I were first getting to know each other, we would start our one-on-ones with the usual, how are you? How was your weekend? But in the US, these questions don't really mean anything. They're kind of like, oh, hello. And so I'd keep it surface level by saying, oh, I don't know, it was relaxing. But Ida would press and ask me more questions like, so what's relaxing to you? How do you like to relax? And that really caught me off guard, because one, that showed me that, oh, she really wants to get to know me as a person. And two, I would have to reveal to her that I played an unreasonable amount of Valorant over the weekend. And as some of you may know, that's not exactly a relaxing activity. And so ultimately, Ida's curiosity in me made me feel safe to share with her when I was struggling with imposter feelings.
And if you're curious, you get to know your colleagues, you get to know your mentees, and you actually can steer them into the right direction. And knowing people or steering them, every person has qualities, and pointing those qualities out is really helpful for their growth, which leads us to our next step, which is giving praise. So a simple good job is already good. If you see something that you like, say it out loud. It doesn't need to be someone more junior than you. It can be your manager. It can be anyone. Everyone feels better. Everyone feels great when someone says you're bringing value to the table and we like what you're doing. Praise is often specific and honest. Empty praises don't have the same impact as the authentic ones.
For example, when I first joined Grafana, I was feeling extremely self-conscious about not being great at Golang, but Ida praised me about other things that she thought I was good at. Like she would tell me that, Kat, people enjoy working with you. And comments like that helped bolster my confidence, which let me focus more so on the journey of enjoying learning Go rather than my lack thereof of technical knowledge in the moment. And so that right there is an example of affirming someone first as a human, Ida telling me that I'm good enough, people like working with me, and then second as a professional, where she would reassure me, Kat, you will learn Go. Everyone has learned a new language.
Yes.
Another tip that we have is challenging negative self-talk. And so people struggling with imposter syndrome may use blanket statements such as, oh, Ida, I'm so slow, I'm the world's slowest engineer. But in these moments, Ida would encourage me to dig deeper with thought-inducing questions. So she would ask me, Kat, why do you think you're slow? What have you been working on? And so by making me answer these questions in detail, I would realize that, oh, I made more progress than I thought that I did. You can also be kind and supportive, and so there's multiple ways to be supportive. You can be technically supportive, and you can be emotionally supportive. And so please check in with your colleagues to see if they're blocked on something or need help. For me, it can take a really long time before I ask for help, because I tend to over-prepare for tasks, so I seem really capable. Superheroism. But if I'm blocked, that can just be a waste of time. So Ida checking in on me to see if she can unblock me or help me interrupts that cycle early on. Sometimes it's through pair programming, sometimes she points me in the direction of other resources, but at the end of the day, I feel supported.
And from the perspective of a supporter or the person who is supporting, you need to start with yourself. In my career, I experienced, and also the two of us, we experienced that if I'm stretched in, if I don't have the energy, if I have too many things on my plate, I cannot, and I'm not kind and supportive towards myself, I cannot be kind and supportive towards anyone else. So self-care is definitely a key to manage this step. Share. Share about your weekend, about your loved one. You can be personal, but not private. If you are really worried about crossing some boundaries, that's a good way to, you can share to some extent, and that helps definitely connecting with your team.
And whenever I tell Ida I feel like an imposter, she would tell me that she's also felt that way, and hearing that made me feel less alone. And so don't underestimate the power of normalizing these imposter feelings.
So giving praise, actively listening, and all of the above that we mentioned leads to connection. Connection not only helps with retention, that people actually want to stay and work on the team, it also helps with people who are suffering from imposter syndrome or other things, that they feel safer in sharing their problems, and then that's the only way how to start tackling it. Also be open. So this advice is great for your teammates, great for your mentees, that you don't judge them, but it's actually great for yourself. So Kat and I, we are cross-culture, cross-gender, cross-race, cross-generation. So Kat is a Gen Z, I'm a young millennial. And like, infamously what's known about the Gen Z, that they are really good with their boundaries when it comes to work-life balance. And when Kat would say like, Ida, you know what, I cannot take this on, I have too much on my plate, I would be like, oh my God, why am I so triggered? And I would explore that and find out, do you wish you could say no to things and you could be more focused on less things or one thing at a time and actually create better work or more quality? And that leads me to mentoring is definitely a two-way street. I think me personally, I definitely got back everything I invested into mentoring. And my growth happened in two different ways. So first one is live by what you preach. If you're holding to or encouraging your mentees to be up to a standard, you need to do the same. So for instance, before Rejekts, I was really having a moment of panic. This is my first soft talk. I was thinking, oh my God, I don't know what I'm talking about. And then Catch reached out, and they were also feeling a little bit insecure. And I told them, you know what? I think what we created in our work relationship, it really means something. I think it's really valuable, and it helped us both grow a lot and overcome some things. And I think we're gonna do a great job. And then since then, I couldn't panic that much anymore because I was encouraging someone else to be more confident. If you feel like you don't know how to do these things, you don't know, you're not a great sharer, you don't know how to connect, this is not your strength, you don't know how to get or give praise, just try it. I'm also working progress in all of these, and you just learn it by doing it. Also, explaining engineering concepts to other people definitely gives you even a deeper understanding of those, so it will make you an overall better engineer. So these are my personal side effects of mentoring. I definitely feel much happier at work since I'm doing mentoring. If you want to be a leader, start with mentoring. That's how you can start developing your leadership skills. Or you can learn how to give feedback. As a mentor, you need to give feedback a lot, and in a very sensitive way, or in an emphatic way. You will definitely improve your communicational skills, and you will become an overall better engineer. So Kat and I, we are really strong believers that mentoring is definitely a great thing to have, and we would encourage all the managers and companies, make it a priority, make it part of your values. Also people, give them time to mentor, not that you code 40 hours a week and then in your free time you should do mentoring. It should be part of your work hours. And also motivate people to do so promote people for mentoring. I really hope we sold you on the topic of mentoring because we really think it worked for us very well.
So although the emphasis of our presentation is on mitigating imposter syndrome from a systemic point of view, we also want to address managing imposter syndrome as an individual living in an imperfect world. So I wanted to start by sharing some of my biggest hurdles when I first did my career switch. Coming from a coding bootcamp and graduating from the coding bootcamp, Grafana was my first software engineering job. Coupled with learning a new programming language, it's safe to say that the learning curve was a little steep. And so I clearly felt my lack of technical knowledge. Some more uncharted territory was the fact that I was the first junior engineer to join my team. And I had to learn how to ask for support, and my team had to learn how to support a junior engineer. I just didn't expect to have so much trouble figuring out how to figure things out, and I really struggled the most with being unable to meet my own high self-expectations. And so if you struggle with imposter syndrome, we want to provide you with some tools to feel empowered. We have some tips. This one starts with tips if you're in a supportive environment. And so I really encourage you to talk to your mentor or a trusted person because they don't know what you're going through unless you tell them, and they can't help you unless they know. So give them an opportunity to challenge your negative self-talk. Another piece of advice I've been using myself a lot lately is speaking up when I don't know things. So if your colleagues are talking about Kubernetes and you don't know what clusters or nodes are, it doesn't hurt to speak up even if you feel like you should know the concepts, because at least if you say something, you can take more away from the conversation. You can begin building your foundation of knowledge.
You never know, maybe someone else is also scared to ask.
And that. So now we have some tips, general tips if you're in any environment, but I think these can be especially useful if you're in a less supportive environment, or maybe you feel like you don't know who you can go to. So I'm a huge proponent of kudos sheets. They're a document where you record your accomplishments, not just your responsibilities. And so you can write down what you learned, what challenges you overcame, and if you don't know where to start, you can ask your teammate to brainstorm with you, because sometimes they see something in you that you didn't. Mindfulness, we believe, is a skill you can strengthen. And so if you catch yourself making blanket statements like, oh, I'm so slow, I'm not good at learning new things, the first step is to catch yourself that you made that statement, and then that gives you a pause and a distance between the statement to decide, do I want to entertain these thoughts? Building community is really important as well. And if you feel alone right now because you don't know anyone who's going through the same thing, it doesn't always have to be that way. And so the way I go about building community is by being vulnerable and sharing about what I'm genuinely experiencing. Because what I found is that even if I casually mention something and it resonates with someone else, it could potentially plant the seed for a deeper relationship in the future.
It's hard to be vulnerable.
It's absolutely hard to be vulnerable, and sometimes it doesn't feel safe to do so. So start small, dip your toes in, feel it out, see how it goes. Some last tips we had are seeking specific feedback. And so instead of me just asking Ida, do you have feedback for me? I could ask her, Ida, we just worked on the ID decommissioning project together. What do you think I did well? What do you think I could do better? And lastly, be patient with yourself. We get better at anything we practice, so get comfortable being uncomfortable. And so we wanted to leave you with the final story. When I first joined the company in 2021, Grafana Labs was really new to hiring juniors. There weren't many details for my level in the R&D progression framework, which is a document that's supposed to describe what skills and knowledge you should have at each level. But because Grafana took a chance on hiring me, it gave Ida the opportunity to hone her mentorship skills, and it gave us both the opportunity to work through our imposter syndromes together. So our point is, hire juniors, hire people who are different than you, support those people, because you don't know what lovely things might bloom from these connections.
Thank you.
Thank you.
Maybe the other one. Let's mix it up.
Please.
You mentioned about, well, that's loud. You mentioned taking time in working hours to do this. About how much time does it take?
So it depends. I think at the very beginning, it's definitely more time. It's also, I think whatever you can give is good. But as Kat mentioned at some point, like sometimes it was pair programming, sometimes it was pointing. I think it depends on your week, but I think when someone's more junior and they are joining a complex code base, it takes more time. I would say maybe at the very beginning, you can also count 50%. And then later on, it just minimizes. But at the very beginning, you should invest in people because then they get onboarded much faster and also they become productive sooner.
And also, like, when I first joined, Ida and I don't think we had one-on-ones every day, but then Ida asked me, she was like, how are you doing, Kat? And I was like, I would like to see you every day. And so, I mean, we were remote, so if I didn't see Ida, it was like I didn't see anyone the whole day. And so it's like, you can negotiate from there, you can like talk with your manager and see what they think, talk with your mentees, see what they need, and so you can figure it out from there.
And also, I think every person needs something else. I think that could be also, maybe we are more on a talkative side of being in the engineering sphere, so we needed more time.
Thank you for the talk. In Germany, we have lots of people have this mindset like, I didn't yell, so that's praise enough. And I exaggerate, of course, but as a young person who changed the job recently, I try to praise my coworkers and the younger colleagues a lot for things that I think they did good. But do you have any tips how to nurture this mindset to get my colleagues to recuperate or to also praise things that they think is good? Do you have any tips on that?
So I think what you're doing is already great. You're role modeling, you're showing what you want to get, but also ask for it. I mean, I know I was also socialized as a woman, it's hard, but just try, like, do you think I'm doing something well? Tell me what it is. I think if you feel not comfortable in a bigger group, just try to set up a one-on-one and ask the people you value their opinion and you think they can give good feedback, just ask them.
And if your teams do retros, I think that's a good way to kind of, if they have that start category, you can be like, I would like to start receiving praise, or I would like you all to start giving me praise, or things of that nature.
I have one about the mindfulness and the kudos sheet. Is that kudos sheet is something that in my previous company we call it the brag sheet kind of thing?
Exactly.
Is the same thing? All right.
Same thing.
Thank you very much again. I think we have some time for a break, like 10 minutes, 20, and then the next one. we're good to go. And we have Benjamin, who's going to talk about storage crash course. Take it away.
Thank you. Thank you all for coming here. I'm really happy to have you. Can you use the mic? Of course, yeah. Hello. Oh, this is weird. Hello. Thank you for coming here. Really happy to have you. We are going to talk about Kubernetes storage today. So first of all, who am I? I'm doing platform engineering at Scandio. Work mostly with cloud native technologies. That's my GitHub. Yeah, this is going to be a talk that's a bit heavy on opinions. So if you see the asterisk, that's an opinion. It might be technically wrong, or it might be a simplification. But we will talk about that. If you have any questions about any of this, asterisk or not, you can talk to me later. I'm going to be around for a few minutes. And yeah, let's get started. So let's first talk about the Kubernetes storage model. Kubernetes does not come with a baked-in storage solution. There's this thing called the container storage interface, which allows you to connect external storage providers to your Kubernetes cluster. And if you want to interact with Kubernetes storage, you use mostly these three resources. There are a few more, but those are the ones that are important for you as a developer. If you're a platform operator, you care about a few more, but like these are the main ones. Of those, you will mostly interact with persistent volume claims. Basically, the role here is you request some sort of storage. You specify some like rough outline, like how much storage you want and from what storage class. And then things happen, and you get that storage. If you specify a storage class, it even happens automatically. So this is called dynamic provisioning, where you create a persistent volume claim, and you specify a storage class in that persistent volume claim, and then things happen, and you get a persistent volume, which there's some laughing back there, but it's really how that works. I only have like 30 minutes, and 30 minutes is a really short time if you want to talk about storage and databases. So I'm really sorry for just like making a hard cut here. So yeah, you provision a persistent volume claim, some backend storage gets provisioned somewhere, and you can use it. There's another thing called static provisioning, which I have never seen in practice before. Another one, the same guy like shaking his head. Yeah, it's basically the same thing, but without storage class. But there is basically a dude coming around and like attaching an existing persistent volume to your persistent volume claim, which is insane. But I guess if you have like 50 network-bound SSDs and you can't be asked to write, sorry for swearing, to write a CSI driver for that, that's apparently how you did it in the beginning, but no one does that anymore. There are also some attachment semantics. You basically don't only care about the first two because the other half of them is just, they exist, but not many people use them. The main ones are the top two, and the difference is you can attach a volume to one node at a time or multiple nodes at a time. And yeah, it's attachment semantics, so yeah, you use read-write once wherever you can, and read-write many if you have to. Yeah, and also let's talk about what kind of storage providers there are. Like storage providers is basically whatever implements a CSI interface in this context. There are like native cloud provider integrations. EBS is an example, Azure Disk is another one, Azure Files, you have like this kind of stuff. The cloud provider provides them for money and writes a CSI driver. You can use them in your cluster. There are like integrations for external storage clusters, like Pure Storage, for example, vSphere. There are also some more exotic ones like JuiceFS. The third one is storage operators. That's actually storage running in your cluster. That's an interesting use case if, for example, you have some read-write once volumes and you need read-write many volumes, and you have a Kubernetes cluster and you want to, like, for example, provision a rogue Ceph in there. That's an idea. You can do that if you have to. And there are also some special use case CSI drivers, like local path provisioning. I think K3S ships that one, just like as a solution to have some sort of storage. And something like the secrets CSI driver, which allows you to mount secrets as volumes in your cluster from like a HashiCorp Vault or something. You don't have to spill the secrets on a control plane. I did a talk about secrets management last year, so if that stuff interests you, I have a talk on that on YouTube. And in general, if you're searching for a CSI driver, or if you want to get an overview of what's available, there's this great URL here from the Kubernetes CSI organization on GitHub, which lists like a lot of them, and including features. Speaking of features, what is CSI? Yeah, it's the container storage interface. Its job is to map an existing storage solution to Kubernetes. And in that role, it handles everything from initial provisioning of the volume, attaching the volume, detaching the volume, resizing the volume, deleting the volume, cloning the volume, everything. Most of the time, it's maintained by a storage solution provider. Some components of it run as pods in Kubernetes. Those pods are stateless, so you don't really have to worry about them that much. And you either install them via Helm, K8s manifest, or it comes with your cluster, so yeah, no modifying node images required. So that's nice. So yeah, how did we get here? Like, there was a time before where all Kubernetes sighing in the back row again. There was a time where every storage provider in Kubernetes was in-tree, which basically meant if you had like a storage thingy, a storage solution, let's call them, and you want to use them in Kubernetes, you have basically two options. One, get it upstream, or two, if you want to use it, for Kubernetes, which like both options don't sound that fun. One comes with continued maintenance, the other one comes with a 6-week release window. So there was this thing called flex volumes, which was the first iteration for doing out-of-tree storage providers. I have never used them. I'm in the industry for 4 years, so yeah. Then second iteration, CSI was introduced, and that became GA. Then the in-tree storage providers were deprecated, which were like, there were some for, I think, GCP, AWS, and Azure. Those were the big ones. And long story short, yeah, CSI is the only thing today. You don't have to really care about much else. There are also some optional features, which some CSI drivers support, some don't. Like volume expansions, most of them support that, but you might have to flip a switch in the storage class. Volume cloning and snapshotting, that exists, but it's not like you can like snapshot between storage classes or anything. If you do a snapshot on Azure Disk, it stays there. And the third one is raw block devices, which basically allows you to get a PVC without a file system. If you want to like put a Ceph cluster on top of PVC, I have done that. Talk to me if you're interested. You need raw block devices, and you can get those. But it's option features. Some support it, some don't. Okay. Really quickly, how does CSI mounting work? Oh fuck, can you read that? Yeah, I mean, it should be okay. So basically, if you schedule a pod which attaches a PVC, your kubelet on the node talks to the CSI node driver node pod, which is the thing that's running on every pod via a daemon set, and tells it, yo, there is like a volume over there, please attach it to this node. And that happens, and the mount directory is shared with the pod. Oh, I forgot the asterisk there, because that's not simple as that works, but it looks like that, so it's okay. And basically that's happened on attached. Just like there's not like magic in there or like some magic like, cloud shit. No, it's a pod that talks to the API. Yeah, it's really good. So how do you select the right provider? Oh fuck, this is so bad. Yeah. Everybody gangster till the storage cluster stops clustering. If you can avoid it, use the easiest solution possible, because you don't want to be the guy that has to like rebuild a storage cluster on the weekend because they decided to like use a storage cluster instead of EFS. There are many options, like the list I showed you before. You can read through that. There are a few interesting projects that are CNCF supported. If you need like exotic kind of storage. If you're interested, JuiceFS is a very interesting one to look at. Again, cloud provider integration. If it's available, use it. Also, most SANs, so if you happen to have like a data center on-prem, they have CSI plugins. I know that Pure Storage has one, that NetApp has one. And if you really want to host your own cluster, use something well established that is known to work, has like an ecosystem around it, and there are like people that know how that works, and you can actually hire people to maintain that. Like Rookzef is an example of that. There might be commercial options, but I don't know of them, but I know many people that know how Ceph works. So yeah, that's that. Yeah, backups. Quick question, like just shout it out. What should a backup do? What are like some adjectives you would use to describe a backup? Okay, I mean, a hot take, but okay, yeah. Okay, that's funny because snapshots are not backups. That's not how that works. Replicas are, by the way, also not backups. If you have RAID, that's not a backup. If you have one backup, you probably can just leave it there and think, okay, yeah, but don't treat it like it's your last hope. If you don't test your backups, they just don't exist. And this is a permission thing. I didn't find how to make this sentence shorter, but I'll explain it later. So basically, if you use some adjectives, they should be immutable, they should be tested, you should be replicating them somewhere, and they should not be bound to the infrastructure, so no snapshots. Which basically leaves us with one option, object storage. And we basically just create a bucket, we shove the data there, and we have to take care a little bit about permissions. You should like separate your backup infrastructure from your regular infrastructure. If it's normal for you to just shove stuff into like a HashiCorp vault or something, and then liberally access that through a CSI driver, through a like secret management solution, yeah, maybe don't do that for the production backups. You should be more restrictive with those. And if you use like S3, there's like this nice feature where you can create keys that can only hide but not delete files. And then you can do a lifecycle rule. So you get basically like eventually deleting immutable backups, which is really nice in a disaster scenario. So for like some specific implementations, there's Velero, the classic. Like everybody knows that. No one likes it, as far as I heard. It was originally built to back up Kubernetes resources, and then they bolted on the PVC functionality when it became available, because Velero is that old. It's a bit of a pain to integrate it with stuff like databases, because you don't want to just like copy the content of a PVC used in a database. You want to dump it or well stream it. We'll talk about that. And the one thing that's interesting that my other solution that I preferred can't do is they can do CSI snapshot, rehydrate those, and dump the content of the snapshot into an object storage. It operates using a daemon set, so yeah, you have to have some chunky daemon set pods for Velero running on your cluster. So yeah, you have to calculate with that. Bigger nodes are better in this case. Reduces the overhead. And the solution I like to use is Ketchup, which is basically a Kubernetes wrapper for Restic, which does backups, and it backs them up into object storage. It has a feature which allows you to snapshot databases as part of the backup process. You don't need to have any like Velero CLI stuff running. You can set that up pretty easily using normal, like a secret and 2 resources I'm going to show you soon. It uses jobs for backups, so you have no static overhead during the runtime of your applications while not backing up. And yeah, you create like 1 backup resource per namespace, which, yeah, this is not a backup, this is a schedule, so it runs like regularly. If you have Restic, this stuff up here should look somewhat familiar, because it's how Restic works. You have some prunes that run and handle retention, and you have your credentials down there, and that's everything, and it backs up everything in the cluster. Doesn't matter, read-write once, read-write many, but you can modify that. So if you don't want to back up certain volumes, you can definitely opt out using an annotation. Also, pre-backup pods, you can dump a database. Talk to me later about this, we're running out of time. So what are alternatives to PVCs? Basically, I'm talking about S3 object storage here. If you have some workloads that don't require like partial object updates, you should consider using S3 because most of the time it's cheaper than object storage per gigabyte, but you pay for downloads most of the time, but not always. And by the way, S3 might look expensive, but there are other options. There are other S3 compatible storage providers, and there are also some non-S3 compatible object store providers. Backblaze is an example for an S3 one, or Wasabi. And for the non-S3 ones, bunny.net is interesting because they very much advertise themselves not having 100 milliseconds 10 to first byte latency. So yeah. And the one thing that's very interesting in like application architecture for S3 is you can create pre-signed URLs, which basically means my server has a bucket, or like has a bucket, has some high-level has some high privilege credentials for a S3 bucket and can delegate a single request which can be executed by, for example, a client. And what that allows you to do is you basically make your client, your server application only orchestrate how a client interacts with your storage, and it's not in the hot path anymore, which is from a performance perspective pretty interesting. What looks like something like this: your client you might just be running like some JavaScript in your browser here, as part of your front end. It requests an upload URL from your backend, and then you dump your data directly into your bucket. I mean, this is basically the same thing. I just changed the how I describe the arrows. It's the same thing, but for download it also works. And what you might also be doing is you might just put a CDN between there to get some more performance. Also, that works with private content as well. There are definitely CDNs that support authentication. So that's not like for only public stuff. You can use that for private data. Okay, so databases in cluster. Like, this is a valid question. Why would you do that? I mean, managed databases from like AWS, Azure, they're fine. They're okay. They're a bit expensive, and they integrate a bit shitty with Kubernetes. That's not great. If you want to do like Kubernetes CD for your application delivery, that's a bit of an issue if you want to do like on-demand test environments. Also, I mean, this is not a big problem with like ACID databases, but if you're using NoSQL databases, some vendors do some non-standard stuff there, like DynamoDB or Cosmos DB. Those are very heavily inspired by existing open source solutions, but are not 100% compatible. Also, latency might be a thing. If you have like a separate data center with some guys running a database cluster, this is mostly an on-premise thing, there might be some latency, which will hurt your performance. Also, what also will hurt your performance, but in a different way, is having to communicate with a database team and writing emails to snapshot databases and like restore them. That's not fun. And with Kubernetes, with running a database in Kubernetes, you can probably move around that. So general advice, if you want to try this, please run a database cluster and use an operator. Use an operator to run it. Helm charts do not count. I know there are Helm charts for MySQL, but they do not work in the way you expect them to because they don't fail over the leader properly. You have to wait until your leader restarts to get like write operations back into your cluster. And that might just take a minute depending on volume attachment time. And if I'm saying a minute, I mean a minute and not 10 seconds. And during that time, your application will probably not work. And also on the point of like failing over, your application has to either do like client-side replication, client-side failover handling in your client library, or you have to handle it on the application level, that your application handles the reconnection event to your database. And as always, monitoring and backups. And the operators all have pretty good monitoring. Just to get through them really quickly, I'm just going to talk about SQL ones, but yeah. If you're using SQL databases, use a low latency, fast PVC, so your performance for your database works is good. If you have a high latency PVC, your database performance will suffer. And also run your database, preferably in the same cluster, because then you can do like secret sharing. That might look something like this. My writing is a bit small. Well, you basically have the separation. On the left side, you have the stuff your users, or in this case, developers, interact with. On the right side, you have all the thing that's the problem of the platform people. And as a user, you just create like 1 DB custom resource, and the operator will generate you credentials, so you don't have to handle those. That's always a good thing. And some services you can interact with, and handles in the backend how the database is provisioned using pods and PVCs, and also does failover. Some example. Oh, fuck. I'm really short on time now. Okay. Postgres, use Cloud Native PG, it's great. Zalando, not so much anymore, but okay, I mean, yeah, you can use it if you use it for legacy reason, but use CNPG if you have to decide now. MySQL operator, I worked with it, it's not fun. I'm not sure if it's a skill issue or whatever, but I didn't get it to work properly. Vitesse, you can use it. It's not 100% MySQL pod compatible. There are some things that might work, some things that won't. You have to validate your application. And just for funsies, Oracle DB has an operator. I have never seen someone use it, but it exists. If you're that kind of person that wants to run Oracle DB on Kubernetes, it is a thing, and it's officially supported. It's great. And for backups, use val archiving and or regular dumps. All of these operators support those on a like operator level. They do that for you. Now this is like the tail end of my talk, where I have 2 things that I have no idea where else to put. Yeah, running storage clusters in Kubernetes, you can do that, but you should do failover on a protocol level. NFS can't do that, so I would not consider Longhorn a good option here. So probably just use Ruxaf. It's a bit more complicated, but in the end it's worth it, not having to worry about, oh, my application just lost all its file handles and can't handle that, because that's the same thing as ripping out the disk. And the other thing is latency. If you use network file systems of any kind, doesn't matter if you host them yourself or not, you will introduce some significant latency to I/O. And even if it's just half a millisecond, that basically means you can do 2,000 operations per second. That sounds like much, but if you want to change on like a whole directory structure, that's not great. And yeah, high commit and flush latency. Have your application handle that if you're doing like I/O heavy applications, and if you have to do maintenance, there's stuff like rsync or rclone, especially rclone, that really allows you to just crank up the parallel transfers for something like a sync or change on, will make your life a lot easier. And thank you so much for coming here. I'll take questions now.
Right on time, thank you. Any questions?
Well, first, that was super awesome to cover that much in so little time, so congrats.
Thank you so much.
I had a question on, you said like snapshot bad, and at first I didn't understand, but then you explained, yeah, if it's in the same infrastructure, that's bad. Would you make an exception for stuff like ZFS, when you can make a snapshot and then send over that snapshot to something else, or is that still bad for reasons?
I mean, you can definitely do that. If you can transfer it out of the infrastructure it exists in, it's probably fine. I would just go with the like more standard way of like snapshotting to an object storage, just for like cost reasons and reliability reasons. And S3 is really easy to provision, and you can pretty much be sure that it will exist in like a year's time. And yeah, it just cannot fail in the way a storage cluster you host yourself does.
Another question, well, except if other folks have questions too. So I was thinking, do you have opinions? For instance, if I'm using, well, let's say I'm doing replicated Postgres of MySQL, I'm in the cloud, and my cloud provider gives me the choice between something like EBS and local NVMe, something like that. And I've been wondering, what would be the scenarios where I would prefer to use the local NVMe because it's kind of faster, but if I lose my instance, it blows up, and scenarios where I would prefer, well, I'm going to use EBS because if the instance blows up, I'm safe, but at the same time, the latency is going to cap my IOPS, and if I have replication, losing the instance shouldn't be a big deal. Like,
that's a very good question. Basically, one thing you haven't considered is EBS have an annualized failure rate.
Right.
EBS can fail. That's not like magic. It hasn't like some guarantee that it won't fail. It can also fail. And I mean, the difference between my EBS volume is failing and my NVMe drive is failing, you're going to have to reschedule anyway. So probably really doesn't matter. Also, if your cloud provider has like that option, they will explain it to you. So mostly it's a performance thing. If you do proper backups and if the cloud provider did their homework, which they probably did, you are probably fine either way. And yeah, it comes down to cost and performance.
and you personally, like, do you see one of them more, or would personally go with one of them more? Or?
Completely depends on the workload. Yeah. Intuitively, I would just go with EBS until it doesn't work anymore.
Okay.
Any more questions?
If you look up the first page of CNPG, they state that they came to this project because you have local disks, local NVMe drives. You can get really high IOPS.
Yeah.
Maybe you can add something to that. What's your experience?
I honestly just have one experience, which is on Hetzner Cloud. I tried like a performance thing there. On Hetzner Cloud, I tried to use Postgres using their block storage, but that just didn't meet our performance criteria. And then we used their local disk. So yeah, they have a point there, and that's basically the same point the man in the back made. It's a performance thing. The local disk will always be faster if you basically have to commit every transaction to disk before it returns. And there's no way around it. You have to probably use local disks. But for most things, you should be okay otherwise.
Anyone else? Side note, I'm the Valero community manager, and you seemed a very nice person in the beginning, not anymore.
I'm so sorry.
Thank you very much, once again.
It's hard to use.
Yeah.
And I'm sorry.
No, it's all right. Our sessions continue downstairs on the main area where Anis is going to do the next one, right? Yeah? Oh, yeah, okay, so we have to rush. Right.